All right, time is 3 o'clock. Very good afternoon to everyone. So our resource person, respected Dr. Mitra sir and Dr. Banerjee sir, both of them have joined. Once again, I welcome all the participants for the day 3 sessions of our AI in certification programs. And with this small note, I request Dr. Mitra sir to kindly please take over the session. Thank you once again.
Yeah, good afternoon, all of you. Thank you very much. Hope you are all doing good. Today, maybe I'm facing some network lag, maybe due to connectivity. So, if any time in between our session, if you find that my voice is not clear or it's breaking, please stop me and let me repeat that particular thing. Okay. So if it happens, so I can find that. The 15 participants are already in the meeting. So should I wait for few more minutes, Mr. Datta, or should I continue?
Sir, I request you to kindly continue because anyhow we will upload the video session also, and people will join slowly because Saturday afternoon maybe somebody may take little time. Thank you, sir.
Okay, okay. So before I start, let me briefly try to recollect what was discussed in the previous week in a very brief way. In the previous week, actually, we have tried to discuss the different types of machine learning or deep learning models, their different strengths, pros and cons, their application areas, theoretically. And at the same time, we have also discussed about different frameworks for developing any kind of ML or DL pipeline. Okay, so we also talked about two different and distinct frameworks. Those are very popular in the community from the industry perspective as well as from the research perspective. One was the TensorFlow, another was the PyTorch. So we have briefly discussed about that. On the other hand, Dr. Banerjee, who was dealing with actually the mathematical implementation and implementation through coding part. So it was elaborated that how the regression algorithm works. He widely and very deeply demonstrated the mathematics behind particular that thing, and gradually have also started that how to write a code of any kind of machine learning project with the help of this like Copilot. Sorry, not Copilot. It was Colab. Okay, so he has probably shared the code also with the data. So probably you have all got it. Have some kind of already exploration that Dr. Banerjee has explained about exploratory data analysis. So these things were already discussed. Now today our main focus will be, as per the syllabus, that the application and adaptation of AI in various different industries. So that theoretical part I will discuss today broadly, and there are a lot of different things that we have to keep in mind before we go for implementing or adapting AI framework in our in solving our own problems in our own industry or domain of work. So what are the things that we have to keep in mind other than the technical things that will be discussed? And tomorrow I will be discussing about artificial neural network, which is actually the backbone of deep learning, which is actually considered the very theoretical understanding of that particular thing and the basic functionality, how it works, such that whenever Dr. Banerjee will be giving you a demo, means problem or it's a toy problem on deep learning, and will be demonstrating with the help of TensorFlow or PyTorch. So it will be very easy to understand how the things are happening. And before that also today, Dr. Banerjee will be completing probably the rest of the things that he was continuing in the previous class. So basically, let me share my screen. So is my screen visible to all of you?
Yes, sir.
Yes, sir.
Thank you for thank you for confirming.
Yes, sir. Yes, sir.
So, in this part of discussion today, we will be deeply focusing on what is the current scenario of this adaptation of AI is happening around the globe. What is the actual figure, and what are the difficulties we may face in adapting AI technology in our already established domains of, or in our working domain or production priorities. And gradually then we will be moving on to the different application areas, and we will try to brainstorm that how AI is being effectively utilized in all those areas, and how we can make our own organization more streamlined and means productive by hand-holding this particular technology. So whatever we are actually thinking or actually seeing in today's situation. But beyond that, in each and every organization or industry, it may be more or less true for the academic as well, but more truly, more applicable for the industry people, whatever we can visit, we can see here in this particular slide, the efficiency illusion. Normally, today, whatever it is happening, too many meetings, too many discussions, too many brainstorming regarding which tool to use and what to not, whether I should use this no-code tool or that particular coding, what are the areas in which the employees are to be trained. So a lot of discussions are going on. So it is a fact that I have found out from the internet and have summarized over here that today we are actually facing a lot of digital fatigue, where tools designed to streamline work and we have fractured our attention. Why this is the thing is that we are more focusing on adaptation of the tool, that what tool to use. So we are switching between the tools and trying to find something fit, but which may not be the actual requirement for the industry or for the production growth. So it is found that 71% of the meeting time is considered that is wasted. And in each and every organization, maybe from it is true, same true for the means academics also nowadays, and industry obviously. A lot of meetings are taking place that this is to be done, that is to be done. But a statistic is saying that 71% of those meeting time is considered to be wasted because that is not contributing directly to the production. And knowledge workers use right now at this particular situation 9.4 different applications daily. So we are actually switching between the tools, so this tool or that tool, like that. Okay, and 21% of the workday is lost simply switching between these apps. So this is very vital information that we have to always keep in mind. So another thing is there, other than actually trying to contribute to the production, means thinking something creative or innovating some kind of strategy, what we are doing, we are actually continuously searching from different information. And employees are spending approximately 1.8 hours a day just for searching information. Okay, so this is actually what is happening, that activity revenue decoupling is taking place, where activity level rise, like emails, meetings, and everything is happening, but value creation stagnates, which is actually happening nowadays, and from where actually every organization should means focus that how to get rid or how to come out from this particular situation. And you all of industry people might have idea about this solo paradox, which we call actually in 1987 a Nobel laureate researcher was there, Robert Solow, who have remarked that you can see the computer age everywhere, but in the productivity statistics. Whenever computer was evolving at that particular decade or century, there was a lot of hype, the same kind of hype whatever we are facing in today's situation with AI. Like what will happen because computerization. So these things was actually widely spoken at that particular time. Whether I should adopt computer or not, or what will happen with the industries, the employees, what will be its future. So something like that. People were more on focusing about talking about computers. So at that time, he had said that you can see the computer age everywhere, but in the productivity statistics. So the hype was everywhere, and the discussion was everywhere. the different companies and organizations like were developing computers, they were highlighted at the particular time. But the industries which was actually trying to adapt, they didn't find any kind of at that particular time. I'm not telling today. So at the very beginning phase, so there was very less improvement in the productivity statistics. So we are actually facing the same thing with Gen AI paradox. We are talking about Gen AI, we are talking about ChatGPT, we are talking about Gemini, we are talking about Claude, we are talking about DeepSeek, we are talking about Grok. So we are searching in the internet, this is good or that is good or something like that. But actually, what benefit we are getting? Isn't it? If I am talking about from the production industry, or the product industries are actually adapting AI or Gen AI, but how much production has increased? Do we have that particular statistics? I will come to that in the AI. Finding any kind of significant improvement in the production level or efficacy level or not. And for like researchers or academicians also, obviously academicians have means got some power in their hand in terms of like what I am talking about, generating presentations, creating notes for the students, generating small tools as well. But does the productivity improve? Productivity in terms of in academic or research, what I would say that are we able to find something innovative? Are we able to do something innovative or which is very critical for the society or for the mankind? Are we actually contributing towards the teaching learning process that are taking place in different academic organization? Is it improving or is it actually going in the opposite directions? Students are also using this artificial intelligence or Gen AI tool. So whether the learning from there is also improving or not. So these things we have to take care, we have to understand. But hype is already there. The reality is that despite of aggressive investment, you can check the diagram at the right hand side over here. So you can find that growth index, if I say, like within the time line 2014 to 2024. So somewhere after the when the deep learning got popular, and maybe from this particular part, means AI has already started becoming a part of different industries and organizations. And from 2023 and 22, the Gen AI actually came into the production level and already has become popular. But if I see that the total factor productivity, if I consider here the investment in AI and digital transformation is exponentially growing. From this curve, it is very much clear. But the if you see the productivity growth, it is not actually improving in that particular exponential rate. It is having a normal linear growth or something kind of a flat. So the thing is that growth, like despite of aggressive investment in AI and digital transformation, total factor productivity growth in developed economics has halved over the last decade. This is the fact. I'm not talking about this, the fact that I have found from the internet, but still it is, I'm also very much surprised. But industry people will be able to clarify this, but not all the industries. Obviously, some specific industries are growing rapidly and exponentially, but specific type of industry, maybe some who are actually, I'm saying, providing hardware for this Gen AI technology. So they are, and also some other organizations which are mainly focusing on prediction or forecasting. They are also seeing some kind of a growth. But it is, if I talk about a general perspective, no, the growth is not exponential at all. It is rather, in some cases, it is downgrading. So what does this mean? Should we actually leave this particular thing? Or should we just go back to our previous situations, which we had the before the this adaptation of Gen AI or agentic AI tool, or actually what I call AIification, actually, the industries, as we are seeing in Industry 4.0, or what if there is anything else. Okay, so the thing is that this is a structural misalignment between the exponential growth and technological capability, and you can see that the linear adaptation of organization framework is happening in this particular thing. So the reason behind it, I will come to the solution and what the solution are being proposed by top researchers and philosophers at this particular time, or industrialists. I will come to that particular part. But actually, what is actually restricting us? So that is very much important thing, and we need to focus on that as well. It is the human brain. We have to, because we are human being, we are actually dealing with this particular thing. We are the industry people, we are the people of the academics, we are actually the part of the system. So we have some kind of bottleneck, okay, which is actually creating a bottleneck in the digital workflow as well. So what are those? The first thing is the biological limit we have to understand. And if I talk about our cognitive broadband, it has evolved at a snail's pace. So see, the technological upgradation and adaptation, the rate of growth in that particular domain is very huge. But our cognitive broadband is also evolving, but it's very, very slow pace. Okay. So our that part of the brain that is called the prefrontal cortex is basically responsible for executive functions such as like any kind of critical decision making or like reasoning kind of a thing, but it is also having a strict limit on it. So there is a popular concept like 4-5 rule, which was earlier 7 plus minus 2 rule. So it was thought that maybe 30 to 40 years ago, it was understood that we, the normal adult or like human being, can keep track of more or less 7 plus minus 2 different items in our working memory. That means we can simultaneously work or think about the 7 plus minus 2 theory. But right now, it has dropped to 4-5 rule. Means we are not capable of working, keeping more than 4-5 items, okay, in our working memory. So what does this mean? So if my memory, my brain have these particular limitations, and at the same time, what we are doing, we are puzzling our brain or particular mind with different types of tools and technologies and different types of jargons and so many things. So what is happening in that particular cases? Another thing is that information obesity is happening, isn't it? So whenever we take too much food and we cannot digest, we cannot use it or utilize it, our fat starts storing in our body, and obesity happens. So in the same time, that whenever we actually we human being normally can process an estimated 403 million terabytes of data daily. It's really a stunning figure, but this is kind of a true. Like whatever the things we are seeing, we are listening, we are sensing. So if I talk about all these things, our brain is approximately processing 403 million terabytes of data daily. So when input exceeds the capacity, so what will happen? The brain enters in emergency processing mode. So right now, in our industry or in this type of Gen AI era, maybe over all academics and industry, across the academics and industry, we are facing this kind of emergency processing mode. So we do not have much time to think and absorb the facts and technologies. We do not have the option, rather, like whether it should be good or not, whether I should go for this or not. So these things are, so we are entering in an emergency processing mode. So which is actually reducing our creativity and actually increasing our error rates. Okay, so for that particular due to this particular reason, what is happening? Our attention residue is also increasing. So we are losing attention at a very frequent interval. So like normally when you switch particular task, generally, so if you do not give a proper gap on that particular thing, what will happen? It is saying, it is a scientifically proven fact that when you switch tasks, your brain does not instantly transit to that particular new job. Part of your focus remains stuck on the previous task as well. So this is actually called as the attention residue. And due to this particular attention residue, the industries are actually facing some blocks mental blocks. And so even brief mental blocks from task switching can cost up to 40% of productive time. So you can easily understand. So this is actually being faced by each and every industry silently, hiddenly, but this is the fact which is actually happening. And this result actually in permanent partial attention. So we are talking about that today's employees or generation or something like that are less effective or ineffective, something like that. So why most of the employees which are experienced right now, which are actually going through this particular transition phase, so they are in a particular kind of a puzzle situation, and due to this is the this is the reason behind this particular thing, and which is actually resulting into permanent partial attention. So if these things happen, so creativity will suffer. Okay, and obviously if the creativity suffers, the production will hamper. So this is a kind of a chain effect. So constantly in motion, but rarely actually cruising in a deep work state. So for this particular thing, what is the solution? So working hard is not the solution. Working harder is also not the solution. The solution is working smarter. So here the technology will evolve, and you all know that technology is changing each and every day. New models, new tools, new technologies are coming each and every day. Okay, so what should I do then? Because being a particular sincere academician or sincere professional, if I am an engineer or something like that, it becomes my moral responsibility that to keep track what is happening around the globe. Okay, so I always have to keep myself up to date. Okay, but if the technology changes in that particular rapid pace, it will be again very difficult for me to grab any particular tool or topic what is actually happening. So what should I do at that particular time? So this is the decision we have to take. So if I go for each and every tool which is coming in the market each and every day, then I will not be able to master or get hold of any of them. So after a certain study or research, I have to sometime what I call that I have to sometime become stable and explore with that particular technology or tool, because my target is not to learn the tool or switch between the tools. My target is to grow, is to increase the productivity, is to solve some critical problems, find some kind of innovative ideas. So these are my goals, not just switching to different tools one after another. Okay, so earlier what has happened now, so earlier most of the times were wasted on checking different logs, writing emails, checking emails, something like that. So which was actually killing a lot of time, productive time for almost all kind of employees from different organizations. But right now with the advancement of AI, okay, this kind of monotonous, boring, time consuming jobs are now being taken care by AI, artificial intelligence. So you are free from that. So you are getting more time right now to think on the problem and how to get a effective solution other than like doing those kind of daily mundane jobs or tasks. Okay, so earlier the metrics was at how many hours you were actually working, how many emails you have sent, how many document you have created. Okay, so maybe the outcome was not that particular good or something like that. Your performance was normally measured based on the hard work you have given. But right now, it is not the hard work. It is the actually the smart work. Okay, so how smart you are in your work environment, in your means organization. So now it has become outcome oriented. It will be the now the the goal will be to check whether the outcome is achieved or not, the purpose is solved or not. It is not that how many hours you have logged or how many emails, how many tools you have checked, what is the things. If at the end of the day you are able to solve this particular problem for your organization, you have achieved it. So no other constraint will be taken. So here you have a lot of leverage, okay, and you have also the power of this particular tool or AI. And obviously, if you go for this with this particular thing, you will be able to achieve an exponential growth or exponential output, because most of your time, most of your boring time, or the time that was wasted with some boring jobs like documentation or something like that, searching, okay, so those jobs, those things are now taken care of AI in a very short time, in a very short time. So most of the time you are getting for innovation, the most of the time you are getting for like what I call problem solving, analysis, foreseeing, visualization. So these things. So obviously, an experienced person, okay, who have a good command in his particular domain, he should be now free to think. Okay, now earlier half of the time for an experienced professional had to do were wasted on repetitive, regular, mundane jobs, and maybe 25% or 30% time he could devote on thinking something new or doing something new. Now the thing is that most of the time, maybe 70 to 60% of the time, you will get for this innovation, for research, for critical problem solving, this particular task. And obviously 20% time you have to devote for this kind of emails and documentation, something like that. So any particular discussion till now, just I would like to ask from the audience, are you getting the purpose of the discussion, or any confusion? Is it clear till now?
Yes, sir.
Okay, thank you. So now these are the things already you know, traditional automation and intelligent automation. So in that particular intelligent automation, there is always a human feedback loop until and unless I'm getting a desired output. So there should be a kind of a learning loop or adaptive learning loop, which is actually the part of intelligent automation, but which was not there in traditional automation. So traditional automation was mainly following a linear flow. Okay, this is the thing that we have to always keep in mind. Our industry are actually means focusing on this particular thing. Maybe right now, those many of you are aware that many of the industry or organizations are facing loss after this adapting AI. Okay, but they are still continuously investing on that particular infrastructure in like AIification, what I call. Okay, so adapting this automation, intelligent automation, smart automation. Okay, so due to this, because historically it has been seen that whenever any kind of new technology or framework comes into the market, they face a kind of a J curve. Okay, so AI adoption is also face this particular J curve, where initially, okay, the investing phase, the productivity actually goes down, okay, with time, but after some time or some years, it will get a rocket growth, an exponential growth. Okay, so this will be unmatched, which is actually being what I call vision by the different organization industries. So this downfall actually takes place due to the technological switching, the upskilling, different type of investment. So like data infrastructure, process design, skill acquisitions. So this type of things happens, and this is happening in different industries as well. Okay, so because initially adapting AI, maybe agentic or something, it is a huge investment cost is also involved with that. Okay, so we are going through this particular phase, but after some years, maybe few years more, it is expected that every organization will face this rocket growth. And everywhere we have to keep in mind that it is we are adapting AI. That does not mean that we human being will be outside of the organization or outside of the loop. No, it is not that particular case. So we have to now come from the in the loop to the on the loop. Okay. So earlier normal traditional model, what is used to happen that humans are bottlenecks they used to be considered, and humans had to approve each and every step from each and every organization. So in government organization we face this particular problem every day. Just to have a like bill cleared, we have to wait for a whole day, one desk to another desk, then from the another desk to another desk. So these things, so approving each and every steps, it was taking a lot of time. So after that ERP system had evolved. Okay, so that particular bottleneck was reduced up to a certain level. Okay, and now still it was already there, that approval of each every step. But in future, what is going to happen? Human will act as supervisors and strategists. Okay, they will not interact. They will not actually what I call intermediate day-to-day regular works. No, those things will be automatically taken care by the AI. What human will do? Human will do intervene only when anomalies will occur. Okay. Any kind of abnormality, any kind of change or switch in the decision making will be taking place, then human being will be intervening on that particular thing. Other than that, everyday regular automatic tasks will be taken care of that particular tool. Okay. So human will come out from in the loop to the on the loop. Okay. And whenever we think that like AI collapses the cost of thinking and exploring. Okay, so it allows a generalist to operate with the technical range of a specialist. So now human being will be having an option to become a specialist from the generalist kind of a thing. So in future, what we need to do is that, or like it is well written in this particular last paragraph, that the future of productivity is not about working alongside AI. To keep in mind, it's about working in partnership with AI. Okay, so not alongside with AI, but rather partnership. So this is a very distinct difference between these. Alongside means what? Alongside means some of my tasks will be done by AI, and some of my tasks will be done by myself. No, this should not be the case, because where the AI will be involved, you directly don't be a part of that particular thing. Keep it for the AI only. Okay. Rather, partnership means if there are different parts of a particular single task. Okay, some which are very much what I call uh, critical, which requires a lot of critical thinking, innovation, or something like that. You human being will be doing that particular thing, and rest of the part, which is actually boring, repetitive, redundant kind of a thing. So those will be taken care by AI, or a small decision making kind of a thing, or prediction. Maybe I have a huge amount of data. So why should I take half of the data and try to predict and give rest half of the data to AI to predict? No, this is not the case. So this is actually being alongside the AI. No, our target will be to work in partnership. So we have to discriminate between the tasks that where we will invest our time and where I will invest on AI to do that particular thing. Okay. So our main focus will be on innovation, critical problem solving, and ideating or formulating problems those are being faced by industry in daily basis. So already I have discussed that cognitive offloading to preserve mental RAM. So cognitive offloading is required. So a lot of things, technical jargons, data. So we have to release our brain, like mental RAM, from those complexity of data, because those are now going to be taken care of AI. So deliberately delegating memory and processing tasks to AI to free up prefrontal cortex for our high value judgment, and it will actually reduce decision fatigue and high quality strategic output, which is actually required from the top professionals in the industry, and obviously will be also expected from different levels of the professionals in the industry as well. And use AI as a thinking partner to simulate scenarios and challenge assumptions. So one thing here, it is very much important to remember that why most of the industry are still facing a lot of difficulties in adopting AI. And they are saying that we are adopting AI, we are implementing the models, applying deep learning, machine learning, and something like that. But still, why the productivity is not improving? Still, why we are not able to find any kind of improvement or growth or any particular change? The reason behind is that the process, because AI is going to simulate your process based on your pipeline. Okay, so if your process is complex and chaotic, so whatever the AI tool you are going to apply, the scenario is not going to be drastically changed. Okay, so you all know that whenever you will be trying to automate a process which is a chaos itself, then obviously, once you try to automate, it will become more complex, more chaotic. So automating a mess creates a faster mess. So this is very important. So before you try to adapt any particular, what I say, process, we'll try to automate it with the help of AI. Always try to make it streamlined first. Try to understand each and every steps and find out the scope of improvement, if any. And the flow of the data in that particular process always must be very much clear. So then only you will be able to implement and automate it with the help of AI. The solution is redesign the process, make it a less complex, linear type of kind of a thing, then apply AI. So if you do this, obviously your growth and return on investment will increase. So one thing you have understood, now those are from the industry or the senior professionals, they can easily understand now. It is not the thing that know about which AI tool will work for me. Rather, it is now the question that how I will make AI tool to fit in our own process, such that my growth, such that I can find any growth in the productivity, isn't it? So for that particular purpose, the process has to be very much clear, and it need to be redesigned if required. It is true for both in the academics as well as in the industry. So if you have any kind of use cases, you can discuss with me any kind of confusion regarding that particular, maybe from the academics or from the industry, that this is the process we are thinking about to automate using AI. So now what are the steps we require to be done before we go for automation or adapting AI? So we can discuss and brainstorm and try to find a solution for that. So in between our discussion, you can also think about that, such that we can discuss one or two use cases on that. And you know that your AI will fail at broken process because automation cannot repair what isn't structurally sound. Okay, so this is a very important line that we should always remember. Okay, it from the industry, maybe from the manufacturing industry or from other industries also, they are thinking about automating, because a lot of investment are coming from outside, from the government also. We are finding we are in touch with different organizations where a lot of fund is coming from the central government or in other organizations to automate, to modernize. Okay, but the systems that are already there in those organizations are so complex and so chaotic that because whenever you would like to automate something, the idea should be very much clear. Now the idea itself is not clear for them or the people who are actually part of the process, so they are facing a huge difficulty in modernization. So this will happen. So until and unless we restructure the things are not going to be changed. If we think that we will stick to our own old process or mentality, and still I would expect growth like modern different organizations, we are thinking broadly, so things are not going to happen. So any particular question till now from the audience, or any discussion?
Yes, yes, doctor. The previous slide you said You first redesign your process and then
Yes.
you use AI to do the automation. What is
Yes.
an acceptable lead time? See, for an AI, right, to develop it takes close to 6 months or something, or at least 6 months is bare minimum. By the time you get some investment, get an IT team, get some coding done, and you go live, it takes about bare minimum 6 months. If I redesign the process keeping AI in mind,
Hmm.
the new process, right, if it does not work in that 6 months,
Hmm.
then it becomes very difficult to change the people, various stakeholders. What is a good suggested lead time between reimagined process, redesign process, and AI getting in?
Yeah, see, here a few things we have to keep in mind parallelly, that whenever we are thinking about automating any particular process, we should always not directly means leave our old one. Okay, so initially we have to think something in parallel. Okay, so after a few times or steps, it will be very much clear about the outcome, what the outcome we are expecting and what will be happening. So once, suppose simple example I'm giving, for, may I know, sir, from which, whatever industry you are?
IT.
IT industry.
Yes,
Okay,
but
so
I'm in
thank you.
IT sales. I'm not in direct IT. I'm in IT sales.
Okay, okay, no problem. So suppose for a simple ERP, so you are means aware of the ERP system. Okay,
Yep.
so whenever any kind of like what I call transition takes place. Suppose a new organization has come and he's proposing that they have a very efficient AI-enabled ERP system, which will change the a lot of things in your organization and reduce a lot of effort. So, being a particular like system administrator, or what I call that admin head or something like that, there should be always a kind of a thing. It is not directly happens that I will directly close my previous one and adapt the new one. What will happening? What will happen is that we gradually transit. Okay, we gradually check that whether any kind of improvement is being noticed from my old process or the new process. And redesigning will be only required whenever we will be facing any kind of technological bottleneck. Because we human beings are capable of dealing with chaotic kind of a thing in many cases, like what I call normally jugaad. But whenever we have to automate a kind of a thing, the process and the system flow, the data flow need to be very distinct and clear, because we need to design the database, we need to design the system architecture, we need to design the front end and each and everything. So if the flow of data is not clear, how it is happening, no automation, no system will stand, isn't it?
That's true.
So any further clarification? Is your doubt clear, or I just deviated from your point? I'm not sure.
The point is clear. I like that parallel run, but
Hmm.
if you can comment from your experience, what is a good time period? 6 months is a good time period to have this parallel run. 1 year is a good time period, something like that.
It will totally depend on the type of process you are trying to automate. Suppose if I are talking about a finance part, okay, finance module of any particular organization. So finance takes place in a financial cycle, like a financial year. So whole financial year we have to run it parallelly to check whether each and everything is working fine or not. So if it is in from academics, okay, so maybe a whole semester or a whole academic year I have to wait for that. Or suppose for any particular production, so you have to wait for a like parallelly run it for a full production cycle, like planning to means selling in the market, or what I call, I'm not sure in your terminology. So just means getting the raw materials and each and everything's what is happening in that particular theory, and selling the product in the market. So this is a whole cycle. You have to wait for particular thing. I think this is advised. Nobody.
Awesome. Understood. Yeah, I understood. Thank you so much. Appreciate that. Thanks a lot.
Thank you. Thank you. Thank you. And obviously, if I am talking about this thing, actually, we human being are very much like emotional in many cases, and this is where India is suffering, like adapting into new mentality, new framework, okay, new philosophy of work. So still, our effort, our effectiveness is measured in terms of hours, not in terms of outcomes. It may be from organizations, any kind of organizations, but obviously in IT industries or in some kind of reputed private organizations. I'm not talking about government. In some government organizations also, the performance is actually measured in terms of outcomes, not in terms of hours. Okay, so first mentality is that our performance, our efficacy should not be measured in terms of hours, rather in terms of outcomes. Means how many effective solutions you have provided in that particular time period. Okay, how many innovative ideas you have rather generated. If you are searching, no problem, you search how many new problem you have found out in your particular domain from the market research. So these are the way if you have to do it, because now in this particular era in coming 20 to 30 years, if I'm not wrong, our target means we human being, our main target will be to identifying the problems and partially write down the steps for the solution. Partially, maybe in coming few years that will be also not required. So just identify the problem, write a kind of a propose a kind of a draft solution kind of a thing. This is your work done. Now rest of the part, formalizing it, devising its detailed pipeline, identifying the resources, tool, platforms, coding, each and everything will be done by AI. Okay, so our target will be that how many innovation we are making in our daily to day-to-day life, how many new kind of problem we are finding. It may be from any kind of organizations or any kind of industry. So this is the thing we have to understand. So we should not be trapped by the metric. So measuring success by hours saved ignores the new work created. That is verification, judgment, and editing, whatever it is. So this is a hidden tax on talent. We have to avoid it strictly. So if here in this particular group, any senior, any senior professional from senior management is there, so I think they can tell more on that particular thing. And this is actually need of the hour. New KPIs required for new era. Many organizations and many companies are also actually adapting it. And obviously, those organizations or a country who will be adapting early, they will progress, they will go ahead faster. And the more delay we will make, we will lag behind. So it is also a critical hour for both our government as well as for all the the public or private industries. So this is a need of the hour. We have to think, we have to change the perspective, change the philosophy. So from activity to impact. So like activity, either how many calls you have attended, how many emails you have received, how many emails you have replied. Still, in most of the like agencies, like call centers or something, the performance appraisal kind of a thing is strictly measured with how many calls you have attended, how many calls you have dialed, or something, how many emails you have sent. No, it's not that. It is impact, that how many problems you have solved, how many value you have created, how much value you have created, sorry, how many innovative ideas you have scheduled. It may be very, very small scale, but if it is innovative, find a particular gap in the research, that will be appreciated. That must be appreciated because that is actually the need. So from a speed, we have to think about to value per resource. So this is already I have said. I will not go for this any further. So it is a choice that whether it'll go for a stagnation or productivity driven abundance. So the future of productivity is not about racing against the clock. Always remember, it's about redefining how to work, how you work, think, and achieve. So productivity paradox, we have to keep in mind whenever we will, if we try to adapt a new technology, specifically AI, in our work domains. So before I move to like domain specific applications, this is also the part of the curriculum. So like evolutionary staircases of industrial progress, briefly it is discussed over here. So I will request all the participants to have a look on this. If you have any question or doubt, you can discuss. Already we have discussed many times in the previous discussions, like industry 1.0, 2.0 in the 70s, 1780s to 1960s. It was mechanization. Then rule-based system came into the application in between 1970s to 2010s. And it was industry 3.0 at that particular time. Now we are talking about industry 4.0 and 5.0. So replacing rigid scripts with learning, adapting, okay, defining, handling unstructured data to ambiguity, agentic workflow. So these are the things. So obviously this particular after 17 and 90s, one thing you have always to remember that technology will grow hand holding with each and every domain. So today we are seeing the booming of this AI and agentic AI or something like that, but it would not be possible without the advancement of other domain like chip design, electronics, or controllers. So without these particular things, this could not be possible, isn't it? So you all know that fact. So this is the normal things. That's constant, like aligning. So mechanization and reorganization of work is very much required. That is the process redesigning I'm talking about. So electric motor has changed this particular shaft power, line shaft power. It is mentality change, switching, visualization. Okay, the dare to redesign. So that is the thing that is evident from this historical, what I call the situation scenario that we have seen. So as you know, that mechanization automated the physical force, but required constant human oversight for control and logic. The innovation was not just power, it was the ability to reorganize the work that I was saying. The dare to redesign or reorganize. Same thing is required here also. So rule-based to deterministic logic model, I have already said this. So this is the mechanics of deterministic system. You all know that the industry and organization, they have a clear-cut idea about this particular thing. So I will share this slide with you so you can see these things. I will not waste much time on this. So productivity index J curve already I have discussed. Now I will come gradually to this beyond chatbot, the rise of agentic AI, which is actually some brief ideation I will be trying to give. Okay, so what is this agentic AI and how it is going? It will dominate industry very soon. Like earlier, whatever the AI models or deep learning, machine learning, what we were saying, our target was either regression or classification, like prediction, isn't it? Like we will be giving a particular, we are asking some kind of a data as output, okay, and I will later interpret that particular data. So I have given some data, labeled data or unlabeled data. There was some kind of algorithm, okay, model which was actually learning from that particular data, and once the learning was taking place, and how to check that if my residue or the error between my predicted and actual result was in a satisfactory level or reduced a lot, then we are thinking that the model has learned, and we used to deploy that in our real life situation, okay, real life or real application area. But in agentic AI, our means desire, our like I call uh, here we do not give the data as input directly. We actually give our goal as input. Okay, directly a goal. Meaning, suppose for example, if I am taking a first a very real life example, so normally whenever I visit a restaurant and we order for a coffee, so what we do, we check the menu card and select the coffee item of our own choice, and we order it, okay, and order it and wait for it. So we never say that like what are the steps in between steps are required to uh, prepare that particular coffee, which machine, which particular module has to be used for making that particular coffee, or which kitchen to use, which particular machine to use. Uh, it is already known by that particular concerned person, the waiter or the cook, wherever it is. If I am talking about a dish, not coffee, simple. So the cook is well aware that what are the ingredients he is requiring to prepare that particular dish, where it is, and each and everything. We, being a customer or a visitor, have to identify our dish and order it. And after some time, it will be prepared and it will come back to me. So here, I'm not bothering about the intermediate tools. Like I have selected a particular dish, I have ordered it. Now, I am not concerned about what will happen next. I will just wait for my delivery. In between, all the process will be taken care by the particular waiter or the cook itself. He will go, he will check that particular order, he will identify the ingredients or the vegetables or any kind of meats or eggs, whatever the different things. He will be using that, taking that from different shelves. Then we'll be cutting it, we'll be mixing it, we'll be using maybe oven or micro oven, whatever it is. After that, it will, whatever the boiling is required or frying is required, the different actions are required in between, okay. So he will take care of that particular thing, and once the food is prepared, he will serve back to that particular visitor. Now agentic tool will be doing what? It will directly take your goal from you. Like I am going to launch a new product, okay, I am going to launch a new, what I call cold drinks in the market, okay. Now this is my the specification of the cold drinks. I will simply, now earlier what it used to happen, if I have thought about designing a launching a cold drinks in the market, new brand of cold drinks. So normal process could be, though I am not expert in that particular domain, but what I have, initially a market study had to be done. Okay, what is the scope of that particular, what should be the selling price, what are the other competitors, like this and that, and after that fixing a particular price, then finding some kind of manufacturing process. Okay, so that is a different task. But if I am talking about a soft part like advertising or something like that, so market research was a big task to be done. And after that, creating a website, each and website, the finding the website, what type of website I will make, okay, what should be the items that I need to display, what should be the what I call design of that particular website, what are the customers I should target. So these are the things, lot of things has to be done or used to be done. So layer my task, my goal requires a different task from different parts. Okay, all are different types of tasks, not a related, but until and unless we combine all the tasks, my goal will not be achieved. So if for a particular goal, suppose G, if I require task T1, T2, T3, T4, different tasks, and those different tasks require some different expertise, a different domain. And at the end, we need to combine this particular thing. Before the advancement of agentic AI, all those tasks was performed by different bodies. Maybe suppose designing a website was a part of the front end guy. Okay, maybe from the design of website also there are two parts. One is the back end and another is the front end. So front end part was taken care of the front end guy. We will be designing about dealing with the HTML, CSS, JavaScript, something like that. The database part was taken care of the database guy, like SQL server, something like that. The file hierarchy, the API design, something like that. Then there was a kind of other integration kind of a task. Now, agentic AI will be doing each and everything on your behalf without further involvement of any other expert. The agentic AI will receive your goal, will understand your goal, then automatically will identify the tools that it will require to solve that particular goal. And also after that, it will plan that which tool or which task will be executed, after which it will fix the sequence, it will decide the pipeline, it will execute them one by one, and finally making the thing ready for you. So, like the analogy that I was giving, ordering a dish and waiting for, so it will function as a waiter, it will function as a like helper in the cook, it will function as a oven, it will function as a micro oven, it will function as a like vegetable cutter or something like that. And after that, it will also test the thing whether the dish that you have prepared is having a good taste or not. After that, it will check its quality and then will deliver it back to you. So all these different tasks will be automated in a single loop, and that loop is known as agentic loop, where actually all the things takes place: perception, reasoning, action, reflection. Perception means understand what is required. Reasoning means after the understanding what is required, what it need to be done, means identifying the pipeline, deciding the pipeline, dividing the things in different tasks. And then action means executing them. Okay, like for website design, I was saying now, the design the front end, like identify design, developing the creating the HTML page, CSS styles, JavaScript code. So these things, also designing the database, creating it, connecting it. So all these things are the actions it will be doing automatically. And reflection means it is not that key you have developed it and created it and just directly delivered. No, it will test by itself whether the goal that you have specified is correctly being achieved or not, or whether it requires any kind of revision, any kind of modification or the, so automatically it will do it. Nowadays, most of the LLMs, popular LLMs like Gemini, ChatGPT, what I call Grok, have some kind of agentic tone. You can also find, because those who are using ChatGPT over last 2 to 3 years, they have found a lot of change or improvement in the way the ChatGPT interacts with the user. Okay, earlier you used to ask a question and it is giving you a answer, and most part of the answer at the very beginning used to be hallucinated. Okay, there was no kind of alignment with the actual and given answers. After that, though, the accuracy was tried to be improved. Okay, 1 minute. Okay. But nowadays you can feel whenever you give any particular task, it first think about that particular task, it understand your task, then starts thinking. It shows that also thinking kind of a thing. Then it works as an agent. Now you will be finding that if you see the progress, you will be seeing that okay, I have understood the problem, now I am searching this, now I am planning this, now I am writing this, now I am executing this. So this is actually the agentic situation. It has now understood your problem and started executing it from its own end, and once it is done and delivered, it will be able to complete the thing. Nowadays the most of the top like LLMs or Gen AI tools like ChatGPT, Gemini, they can do a lot of things in agentic mode for you. It can book a ticket for you, it can reserve a railway ticket, it can book hotels, it can do market search, it can, according to a specification, you can give you a summary, you can design a website, it can, I'm not sure that what it cannot. It can do many, many things. So this particular things is going to be agentic. Now, how whenever this kind of things will be adapted in industry, that means all those people, those were used for perception, reasoning, action, and reflection will all be automatized. Okay, so human intervention will be reduced a lot in all these phases. Okay, so that means what? These all these things will be automated and would be made smart with the help of AI. But there will be a human intervention at the top, as I was saying, na, on the loop kind of a thing. So task automation, just clicking a button, generative AI, agentic AI. So these are the things. So earlier it was kind of at the very beginning, the task automation was like clicking the button kind of a thing. You click a button, you get a particular thing. Then generative AI came, where you were giving an instruction to write a mail, summarize it, or something like that. Okay, it used to do for that. But agentic AI, it will be taking a more complex form, like resolve this compute customer complaint by researching the policy, updating the database, and emailing the client. So you can see here there are the three different tasks for which, like researching the policy, updating the database, and emailing the client. Three different tasks, and for each of these three different tasks, three different tools are required. Okay, so this agentic AI will keep track and will orchestrate all these tasks and tools simultaneously. So agentic AI takes goals as input and acts autonomously within that defined policies. So these are the things. I'm running short of time. Any more questions? Any queries till now? Any question? Okay, so now I will be briefly discussing about the application areas in different domains, as we are having here the participants from different domains. So here I will expect your opinion and input that give me any particular problem, and we will try to see that how AI can be used to solve that particular problem in your domain. So initially, the core intuition will be like we have to reframe our relationship between human expert and machine. And the most effective way to conceptualize AI is not as a replacement for the expert. I am emphasizing it, focusing it repeatedly, that it is not the replacement of human expert. This is a myth. This is never going to happen. AI is not going to take the jobs. Rather, it need restructuring. Okay, so a replacement for expert, but as a bright, eager, and tireless intern. Okay. So AI will function as a junior analyst. It will have require a capability like fast, incredibly fast at crunching numbers, summarizing vast data, producing fast drafts, never tires. Okay, so these are the repetitive, boring, mundane jobs which human had to do earlier, but nowadays AI will do this for it. You. And the limitation was that key, it lacks deep context, strategic judgment, and nuance. This is very important, the nuance, and prone to blunders without specific prompts. So this is the limitations, and this is the capabilities. And this, if you see it properly, this first one is our limitation. This is a limitation of human being, and second one is the strength of human brain. So why not exchange? Okay, so make AI do this thing, and human will do from the strategy. It is having his empathy means ethical development, ethical judgment, handling ambiguity capability. Okay, so this is capability, and the role will be to define the problem, delegate heavy lifting kind of a thing, rigorously review the output, and validating the accuracy what is happening. So it's the kind of a senior supervisor or professional who will be keeping track what the juniors are doing. So here juniors means the AI. So it will reduce your cognitive workload that I have already said. And co-pilot and autopilot. Okay, so either it was moving from autopilot, it was autopilot kind of thing, set and forget, but now it is a co-pilot, that is interactive assistance. Okay, so now uh, most of the AI tools that is having are available as a co-pilot, means you initially continue doing the things, take help of AI. So this co-pilot facility you can find now everywhere. Those who are using Gmail, they can find that Gemini as their co-pilot. Those who are using like VS Code for coding, they can find GitHub giving a lot of options on Copilot. Windows are also Copilot means you are working, but some assistant is ready for you. We will be assisting you all the way. So you can in the meantime or in between, you can give prompts at any time. Like you give define goals and constant, and you can suggest the things what is need to do. Okay, so here the three things are there, like drafting, summarizing, and search space. Okay, so the thing is there, prompting, then from suggest there to suggesting, and then verify. So user will be acting as an editor in chief kind of a thing, who will be checking each and everything whether it is accurate or not. But this is avoid mental cruise controls. It is always remember that these things should happen, that we have given an AI and we are relaxing. No, this should not happen. Okay, we should always oversight it. We should always check what is happening in between. And this is the thing, the orchestration is required. Earlier, if I sing a traditional normal day, most of our time was checking that email triage, calendar checking, okay, manual search, typing, so different things which are not that much important. But right now in an AI augmented day, so I will be checking a morning briefing, what is happening around the globe, then think about deep work or strategy, you take more time on that. Okay, then context aware scheduling, you can go for listening to different kind of relevant documents, something like that, or what to do or something like that, so you can schedule your context on that and reviewing different notes. So repetitive, mundane, boring tasks should be avoided from our daily schedule right now in this AI augmented day. So this is, has to be noted. So business process into automation, if I'm talking about now briefly, I will take more 10 minutes time before I hand over session to the Dr. Banerjee for practical. So business process automation, you all know here a lot of things can be done. Like we need to embed this intelligence inside in your ERP system. That is the planning software. That is actually the backbone of the organizations. You can means embed AI to automate, innovate different tasks to reduce the error, improve the efficiency all over the time. Okay, like simple invoicing, auditing, sales record analysis or something like that. In each and every phase, you can apply AI. So if anyone from the industry would like to have any kind of question on business process automation, they can ask such that we can discuss that in this way the things can be done. Any question from the industry about business process automation? So are your organizations thinking about embedding AI into your ERP, or they are already embedded it? Any response? Those who are from IT industry or any other industry, may I know that whether their organizations have already embedded AI in their ERP system, or they are thinking of it, or not interested?
Yes, they have significantly started embedding AI into systems.
Steps are on progress phase also in my organization.
Yes, actually, your voice is not clear. I couldn't hear properly. Will you please repeat? Will you please repeat? I couldn't hear properly. Hello? Okay. Anyone else? So may I have some kind of example that this is the place where your organization is actually thinking of embedding AI into, like any particular decision making or analysis task?
Sir, may I ask a question?
Yeah, sure.
Sir, I'm working in a teaching medical hospital. We're a research. I'm a research scholar. What is the kind of AI application that healthcare industry can have, especially a teaching hospital?
Teaching.
Yes, sir. We are a medical college.
Your medical college. Okay, I will come to that very soon. Please keep your question in your mind. I will
Right,
come
sir.
to that very soon.
Thank you, sir.
Anyone else?
So normally what happens is this person is going to a customer, and customer is giving some kind of requirement. So I want XYZ products. I'm building a data center, or I want you to put a wireless networking system in my college or hospital or my campus, many places, and then we have to give some kind of quotes. Now the quoting system itself is completely I wouldn't say 100%, but more than 80% to 90% it is non-human touch. Meaning all you have to do is just punch in the requirement, and it's able to go and identify the right products. It is able to prepare a quote. It can look at email exchanges from customer and the sales rep, and be able to draw up a very professional quote, and also find it can do multiple. The customer is not accepting this. He would like to have a discount. If you say, then it will go and see from what permission it was given, and at what levels, like a vice president, director, country level discount is possible. It will automatically give you the discount also. And redo the quote and give. This used to take a long time. I mean, sometimes when you call and ask people, can you give me a quote? They will say, okay, thank you for the requirement. You will get a quote in like 3 days or 1 day. Now it is done, just not even click of a button. You just put the input, and then next minute you will get the quote in the email.
Yes. So is your organization already doing this, or you are?
Yes, we are already doing this.
Very good. So actually, this is actually the advantage, and that what was needed is that have a kind of 1 or 2 or 3 meetings what I will I will guess that what happened before making this particular tool and deciding about the pipeline of the steps. So whenever a code request was coming, what you used to do, just write down all these things. The process, this is the process what I was talking about. This process idea must be very clear. So when a code request will come, I will do this first, then this, then this, then this, then this. So once this is done, now it is the responsibility of designing a well guided pipeline and then code it. Now for this particular purpose, a different tools will be requiring, and automatically a software will be prepared, and we will be doing all the things at once, isn't it? So deciding the pipeline or the flow of the process was very important. This was the most crucial, and I am quite sure that most of the time your team had invested on designing that pipeline. Any more question? Any more comment? Business process automation. Okay, so just quickly move to the next part. Here, one thing is very much required to understand that industry and enterprise, in most of the cases, the asset life cycle, then this is mostly for manufacturing industry, I will say, where the assets life cycle actually the what I call performance suddenly drops after some time, isn't it? And we have to like exclude that particular asset, or we have to what I call remove it. But this was the earlier process that after functioning properly for a certain period of time, suddenly its performance drops and that particular asset become obsolete. But one of the main reason behind that sudden failure was the lack of predictive maintenance. Now, AI is giving us the capability of predictive maintenance. So, most of the assets, because in many industries, they use like what I call instruments of crores of rupees, isn't it? Now they are having different sensors which are actually keeping track of that particular working of that particular instrument or device, and the data of those sensors about its performance, the different parameters based on which that particular device works are also being recorded. But those data were never checked properly, whether are we getting any kind of, or were we getting any kind of indications that the health of that particular device was deteriorating, or some kind of fluctuations in its performance is happening or not. So if we take the data from those sensors which are actually attached with those particular device, or any kind of data that are coming out from this particular device, and we can analyze that, check it that performance of that particular device is somehow getting affected, though it has not stopped suddenly, still it is working, but somehow some kind of anomalies, some kind of disturbances is being noticed. And based, if you can find some pattern in that particular data to find out that the performance of that particular asset is somehow getting disturbed or deviated, then based on that particular data, you can track the sensors from where it is coming, and based on that you can perform some kind of maintenance. Okay, so this maintenance will enable you that the system or the particular device should not stop functioning suddenly. It will help you to identify the probable error, the problem that is going to happen, and based on that it will, you can perform some kind of maintenance repairing work such that it works longer. So it was mainly, earlier it was mainly reactive, fix when broken, unplanned downtime, but now it is preventive. So schedule intervals are there, okay? But predictive AI, which is coming, it is mainly data-driven, sensor-based. So data-driven anomalies will be coming, and based on that, you will be able to do some kind of predictive maintenance. Means this is going to happen, because no device suddenly breaks, suddenly stop functioning. It many cases it's suddenly, but this is the thing. But sensors in complex devices, sensors give sensor data, give some indications beforehand. If you can analyze them properly, you can give an idea that some anomalies are happening within it, and based on those anomalies, you can give some kind of downtime and maintain it and function it again. Education and research. I am from academics, so I can now understand the power or the advantage of these Gen AI tools. But the thing is that we have to become more like sincere, serious and obviously very much careful while using these tools. Obviously, this Gen AI tool will help you to plan your lecture, to decide your analogy, examples, questions. Okay. Also, the evaluation in many cases, designing PowerPoints, giving assignments. So these things are happening every time. And also, I'm talking about teaching first, but we have to always keep in mind that our students are also using these tools. So if we use the same tool to generate the things of same standard, then it is of no use, because many students are more up to date. They are aware of tools, many more tools which I, being a teacher or an academician, are not aware of. Okay, so they many times they show me some kind of fascinated kind of a things. This is happening, sir. Check this, check that. So I feel, okay, from where did you get this? So they will be saying that I have got it from. Are you aware of this particular tool, that particular tool? So here my comment is that we need to be, being a teaching professional, we need to always remain 2 steps ahead from our students in terms of technological updation, is what is happening around the globe. Number one, we have to always be aware of that. What are the tools, technologies? At least if you are not accustomed, or if you are not means what I call comfortable in using them, but we should know about how those things works. Number one. Number two, we should be capable of identifying the hallucination that are provided by AI. So we should always carefully check the documents those are being generated blindly by the students or something like that. And we being a teacher also, we should take care of blindly generating the things. So whenever this is a common tendency of human being, this is all. Because see, if I have asked about a particular paragraph or the answer of a question and it is generated by AI, I start checking first 2 or 3 lines. And if I find that the answer, start of the answer is very good, so I do not check the rest of the part and give or disseminate with the students, among the students, forward it with the students. So many cases, we make a mistake over there. I have found maybe in some later part of the paragraph, some hallucinated wrong context or wrong content is given. And if blindly, without checking it, if I distribute it among the students, I am giving a wrong information. I am distributing a wrong information with the students. Because students are not aware of that particular thing. Whatever I will be saying, I will be giving them, they will be blindly, what I call, admit, blindly take that. So we being a teacher here, have to be very much careful in sharing the AI generated content. Number one. Number two, we should devise some kind of innovative mechanism such that Instead of like using tools, AI tools, some kind of innovations we can identify, we can evaluate the innovation, reasoning capability or learning capability of our students. So these we have to keep in mind. Now, becoming an academician, if I am talking about research, AI is a fantastic tool. I think many of you are using, those who are from academics and research, do research regularly. So AI has now become so much like powerful in doing research on your behalf or assisting your research, that you can now jump into any kind of complex problem. But the thing is there, whenever these powerful things comes in the market, our normal tendency will be to generate whole things through AI without checking or without digging into the things, what is being given by the AI. Now, what will happen in this particular case, if you are generating some idea in your mind, okay, and if you try to create the whole concept, develop the whole concept with the help of AI, your idea may be lost. Lost, I'm not talking about it will be like taken. No. Lost means you will forget actually what I personally face, that what I was earlier thinking and what AI has given. So our idea, our thought process will be fully aligned with AI, what that particular tool will be giving back to us. This should not be the case. AI should be our assistant. But if we use these AI tools without proper caution and without any particular focus, we will become the assistant of AI. Meaning it, AI will make me doing research in its own direction. So this should not be the case. I should be very much clear that this is the problem that I am searching for. This is the part I will try to generate. I will check. I have the concept of this paragraph in my mind. I will brief it. Then I will take help of AI to regenerate and rephrase that particular paragraph. And then I'm well accepted in putting that paragraph in any kind of research paper or anywhere. Nowadays, researchers and academicians, they know very well that most of the reputed journals and conferences have made it very clear through notification that they have no objection with the manuscripts which are written with the help of AI tools. But it is to be made very clear at the end that which AI tool you have used particularly for with what purpose. You have to list all the things. So there it should not be the case that the domain was generated by AI, the title of the paper was generated by AI, the abstract was written by generated by AI, the paper planning was also generated by AI, diagrams were generated by AI, equations were generated by AI, till each and every sections were generated by AI, and I am publishing it on my behalf. And I'm quite sure this is happening, and those who are senior academicians and researchers, they will also agree with me that nowadays it has become very difficult to segregate or to what I call differentiate between a human written paper or manuscript and an AI written. Because if the paper is of well standard, well written, I can never say that it is written by AI. If I say this, I am actually, what I am doing, I am saying that that particular author have no capability of writing that kind of standard. We are human, a good researcher can always write a good paper. So if the paper, quality of the paper, writing of the paper is good, that does not always mean that it is written by AI. Actually, journal accepts, journal actually, what I call desire, intends for that. Paper should be well written, well structured, diagram should be good, well structured, equation should be clean, references should be okay. So whenever they are getting it, They cannot directly say this is written by AI. So here the actual problem is arising. And here all the researchers has to become more ethical, more responsible to check, because once a fully fake thing which is have no ground or something like that is published on your name, and later if it is retracted, then your whole reputation will be hampered. Now I am naming few tools which you can try. Nowadays you can find that OpenAI has means brought a new tool called prism.openai, which is a substitute, I can say that, of overlip. So those who actually you are any one of those use overlip for paper drafting and writing in latex?
No.
Overlip you use for latex paper writing using latex overlip? None
No,
of
sir.
you?
No, sir. Till now, I have not used.
Overlip, OVRLEF. So how you just don't you use latex for document writing, paper writing?
No, sir. No, sir, we are using only Microsoft Word
Okay,
manuscript.
okay,
So that we want to learn. Actually, I don't know about this latex and overlay.
okay. But most of the
We
journals
use
actually,
ChatGPT.
right? If you want to write a paper in a well-structured manner, okay. If
Yes,
you
sir.
just focus on the thing that you have to write, because in Word, obviously, but in Word, a lot of difficulties like regarding referencing, citation, table handling, image handling, alignment, text, fonts. So those things are actually, if you focus on that, then your main purpose somehow will get hampered. So I will always suggest that go for latex, okay, whenever you will
Okay.
be writing any document. So
Thank you,
earlier
sir.
Overlip was the most popular tool. Nowadays OpenAI Prism has come, which is a substitute of that, which is already integrated with like ChatGPT, is 5.2, GPT 5.2. With the help of prompting also you can write latex code, so those who are not using.
Yes, sir.
Okay.
Thank you, sir. Yes, sir.
And for research, you can use deep search option for ChatGPT or Google Gemini or Perplexity. So deep research will be giving you a more, instead of giving normal search, give deep research. Use that particular option, give a topic, and then you can get a lot of insights with some genuine references.
So what about size space?
What? SciSpace.
Yes, sir.
SciSpace is also a good option, but if you want a directed search, okay, directed search for a specific particular topic, then obviously there are many options are there, okay.
Okay, sir.
But right now, Perplexity and Gemini and ChatGPT, okay.
Okay,
So
sir.
deep
Okay.
research option in this particular GenAI tool is always a good option. You can test it once, and then you will be able to differentiate by your own, that
Yes, sir.
which is the strength of that. See, now whenever we have those powerful tools, okay, if you do not use them and someone else use that, so they
Yes,
are becoming more fast, isn't it?
yes, sir.
So we have to
Yes,
use it.
yes, sir.
We have to use it. So if someone else are using, so same idea, because it is said that whenever you are thinking of any particular innovative idea and you are discussing it with your friend or your colleague today, right now, be sure that at
Yes,
least 100 persons around the globe thinking of the same thing, same idea simultaneously. It may be any, it may be whatever innovative, but people are thinking. So simultaneously, a lot of researchers are working on the same thing. So if you are not fast in framing your idea, documenting it, writing it, and publishing it, tomorrow it will be published by someone else. So you have to be very fast, and steps
yes, sir.
should be very much calculated. Okay.
Thank you. Yes, sir.
Okay. So healthcare, someone was asking that from
Yes,
medical colleges how they
yes,
can
sir.
use.
Yes,
Uh,
sir.
They use AI for their purpose. Okay, see, there are a lot of options. Rather finding of options, you can also start with LLM. Maybe Gemini can be a very good option. Okay, so I will request that go for subscription of at least one,
Yes,
anyone.
sir.
Okay,
I have
so like
ChatGPT.
ChatGPT, ChatGPT, isn't it? So ChatGPT, Google Gemini, any of them. Grok is also good. Another option is there, Claude and from Anthropy. But ChatGPT is a general purpose. Okay,
Yes,
it
sir.
is
Yes,
good for most of the tasks from different domains. So you can explore whatever questions that you are having. That in how many different ways you can use this
yes, sir.
AI or tools for your teaching. Now I am telling
Right, sir.
you that starting from infographics in your domain, infographics is very crucial.
Yes, sir.
Like what is
Yes, sir.
happening, suppose how
Yes,
the flow of blood takes place in and around the heart. Okay,
yes, sir.
so and very good tools are there. If you can display that with a short video or infographic, it will be more intuitive and attractive for the students rather than that. Okay,
Yes, sir.
so generating a very good presentation with the help of Gemini. Another is
Yes,
also there, like Notebook LM. You can also check
sir.
that. Okay,
Sir.
so with the help of that, you can generate attractive slides and presentations accurate, but obviously cross-check each and everything, because in your domain, a single
Yes.
hallucination
Yes.
is fatal.
Yes, sir. Yes, sir.
A single wrong statement is very fatal. That's why, the scope of error is very less in medical domain. So that's why it is the medical domain where actually people are more reluctant in adapting AI, because
Yes,
they are
sir.
still, researchers
Yes.
still not that much
Output.
confident about that
Sir.
accuracy.
Yes,
Okay,
sir.
for
Yes.
manufacturing industry, 5% failure is not that much important, but for medical domain, 5% error is very much significant. Okay,
Yes, sir.
so that is why. So in for teaching, deciding about innovative pedagogy, lecture materials,
Sir.
developing quizzes, infographics, short videos, images with the help of Gemini. For any kind of image related thing, you can always go for Gemini. Okay, Google
Okay.
Gemini. This is a very good option. And now you can have a subscription to Gemini Pro with the help of your Geo phone account, phone number as well.
Oh,
Okay, and Gemini Education is also available. If you have any your domain, college name, domain email ID, with that also you can get access of that particular thing. Okay.
yes, sir. Yes, sir.
So other than that, for your medical research, it is also widely being used. You can use exploring data's classification and all. Okay, so you can use it. Actually, in
Yes, sir.
medical domain, there is a wide application of AI nowadays, and teaching also. In teaching, more pedagogical, customized teaching, it has become more easy with the help of AI. So if you have any specific question, they said that how can I get this particular thing solved, but or in teaching you are facing this difficulty which you want a solution with AI, you can ask.
So, to what level should we, when we are publishing a paper, we have to give like this much assistance has been got from AI. So, I mean, but literature search we are doing with AI. Then some these tables figures we are getting with AI help. So, how? I mean, which part do we have to inform the journal, or do there is no need to inform for certain activities?
No.
Which
See,
are the ones?
you need to inform the journal, because see the tools that you are using for generating this particular thing, isn't it? Actually, there are also some tools, though it is not always accurate. If it is blindly created, then some tools are also there through which they can check the AI content as well. Now the thing is that if you know, see what type of table I am talking about. Suppose the suppose for in COVID time, if I am talking about in 2020, I want a table, state-wise table, that over 1 week of time, what was the growth rate in COVID positive cases? Okay, in
Yes.
every state. Now,
Yes.
this table does not require any kind of
Yes.
like innovation or kind of a thing. It is just accumulation of data from different sources and giving it into a table, isn't it?
Yes.
So this table you can always research directly through agentic system. You can directly ask any deep search tool that search in the authentic websites with resources and find out the data and populate in a table with these type of rows and columns. It will give you. Okay, so there is no problem with this.
Okay.
But suppose in your research you are trying to find some outcome in an experiment. And
Okay.
you have elaborated that experiment to ChatGPT or something, and actually didn't perform the experiment, but you are asking the ChatGPT to define the outcome of that experiment and give it in a table. So you have never performed the experiment, you have given the idea of the experiment, and you are asking the result of the experiment from the AI.
That is generated data.
Got
It
it?
is not.
So never do that. So never,
Yes.
that will be a kind of a unethical thing. So
What
if you
about
do ethical stuff, yes,
What about statistical analysis, sir?
statistical
Stati-
analysis you can always do with the help of AI tools. Actually, they are suggesting to do that because
Yes.
whatever earlier people used to do with mathematics, formulas
Yes.
in Excels, now they
Yes.
are being done by what? Packages, libraries, simple in
Yes.
Python, or tools. So there is no harm in
Java.
it. Backend, the same statistical formula is working.
Yes, sir. Yes. Like Jamovi
There
is
is no.
working with our libraries. Uh,
Hmm.
Jamovi
No
tool.
problem. No problem. No problem. No problem.
Yeah.
Any tool you use, but your diagram should be clear and it should
Yes.
be made clear to the readers as well as
Yes.
for you.
Yes,
And it
sir.
should be well cited in your manuscript as well. The outcome of
Yes.
the insight of the diagram that should be clearly stated.
Thank you, sir. Thank
So
you very much.
you can use AI for rephrasing your paragraph, organizing the sections, planning the sections. You can use AI, no problem with that. But do not generate a full paragraph or content,
Yes.
okay, out of
Yes.
nothing.
Yes, sir.
This is not ethical. This should be
Yes.
strictly avoided.
Yes. Yes, sir.
Okay, am I
Thank
clear?
Yes, sir. Thank you,
Okay.
sir.
So this is the thing I was saying. And if you approve any hallucinated information in any of the prompt, and based on that hallucinated information, if you continue the research, the hallucination will be amplified, bias will be amplified in consecutive things. So, where not to use AI and where to use AI. This is very much important for all the participants. And like we call green signal, that use AI, obviously, objective data analysis, high volume, repetitive task, drafting and suggestion. Clear, drafting and suggestion. It is not saying writing and outcomes. It is suggestion and drafting. So final version will be you have to take responsibility of the final version. And like human in the loop, HITL, is mandatory for ELO situations. Like you can use AI for these particular purposes, like complex code generation, external communications, noisy data domains, but there should be a human in the loop. HITL means there should be a, suppose if someone is using AI for coding or developing a website, an experienced web designer or a programmer should be there in that particular loop, which will be acknowledging or defying the like means avoiding or discarding the unnecessary things. And red, where you should not use AI right now, only human should be involved. That is for moral judgment, ethics. Please never ask AI which is ethically correct. Still now, if you are human being, based on your culture, your our constitution, our civilization, we have a very strong ethical ground. Okay, so AI can give you a lot of suggestion, but final judgment is yours. So moral judgment, do not rely on AI, because it can maybe not all, because many companies like Google, they are very much concerned about the ethics, and they never go against human means civilization in most of the cases. So they are majorly ethical, but still do that. So ethics require conscience, not statistics. So for this particular purpose, do not use AI. And high stake decisions like life or death outcomes, as for medical science domain. So there are a lot of human consensus required. So in that particular cases, you can use in worst cases AI in the loop, but the final decision should be taken by the human expert. And for chaotic processes, if you can draw the flow chart, you can't automate it. Suppose sometime in a particular area, uh, a clash has taken place, or many people are fighting with each other, and at that time, if you go ask ChatGPT, keep the photo of that particular chaos and ask how to stop this chaos, so they are not going to get any help. So in that case, you have to come forward and apply your own intelligence and intuition to solve that matter. So chaotic process, obviously, don't use AI. So this is already I have said, and I'm already too late. Too late. So I think now the time has come to hand over the session to Abhijit. So before that, if you have any questions from today's discussion, I have said a lot of things. And if you have any doubt or query, you can ask. So in the meantime, if Abhijit, you are here, can you hear me? Dr. Banerjee?
Yeah, I'm here.
So are you ready?
I'm ready.
Okay. So if anyone have no question, then I'll be happy to hand over my session to Dr. Banerjee. So if you have any question, you can ask.
Hello, good evening, sir.
Good
I
evening.
would like to know about result and discussion. Can we do with the AI tools?
No.
Result and discussion means full result and discussion.
No, part of it.
See, if you are sure about the result and discussion, if you have the results are not AI, results are of what? Results are of experiment or
Yes,
algorithm, isn't it?
yes,
So
yes,
if your algorithm will give the result, not the AI,
yes,
number one. And discussion means if you are sure that what are the things needed to be discussed, then you
yes.
can use AI to formalize the same. But
Okay,
do not ask AI to write the full result and discussion session. If
yes,
your experiments give the result
yes, sir.
that you are actually desiring, and if the state you are clear about what are the things needed to be discussed, then you can use AI to formalize the same.
Okay, sir. Thank you, sir.
Anything else? Okay, so thank you very much from my end. Now, Vijit.
Is it visible now?
Yes, sir.
Yes,
Yes.
sir.
Uh,
thanks to Dr. Thakur because for taking up this time because I'm not in the right state of mind today. I'll be very slow. Uh, there are certain things which has happened in my life, so I'll be very slow. Uh, right now, before going into the depths of your coding and all, I'd like to clarify certain things that have been pointed out by other participants here regarding both academics as well as business. I'll start by saying a single thing. This should be your mantra if you are going to use your AI, any sort of AI. It might be a generative AI, it might be your ML and all. Everything is this. Never fake. Faking is dying inside. Never ever fake your results. Never ever fake your empirical suit because it may be in business also. For example, in a sales data, I want to show a progress in my own sector and I'm faking my data, but then I'm dying inside. Do not do that. And AI can do that faking part very easily. Do not rely on AI or any sort of generative models for your data. Second is garbage in, garbage out. What you put into the AI is exactly what you are expecting from the AI out. So the data, the domain expertise that you have should be of more importance than the knowledge what the AI has. You as a human being is a driving wheel, not the AI. AI is something which is looked upon as a tool rather than something which is going to replace the humans. The human touch, as Dr. Thakur had rightly said, is more important. So do not underestimate or overestimate the power of an AI. Always put yourself into the helm and put the data right. Do not reinvent the wheel. And this is specifically for both the segments, for the business oriented people as well as the academics. If your job is to analyze and provide a data of sales or any sort of logistics and stuff, say for example, Mr. Murli was talking about quotation and all, and you know that an AI system is much more efficient than a human being, you need not reinvent the wheel and put a human in it. The human would be the first part who will be designing that pipeline, and that's it. So do not reinvent that. Example from the academic point of view, people who are writing their thesis and all papers, you can use AI for your as a tool, absolutely fine, but use your own empirical results. But if you are from a medical background and you are into coding in R and stuff, that is not required. Your primary job is to uh, provide an empirical result for the benefit of humankind. So maybe you can offload that R programming statistical part to AI itself. AI can do that right now using agentic systems. Concentrate on the domain in which you are expert in, not on
Yes,
something
sir.
else which is not so meaningful for your end goal. Keep it simple and stupid. There are umpteen number of times I've seen people who have used big algorithms, big ML algos, mostly in IT segment where uh, quotations of an R&D is much more floated and bloated. So you need a simple regression model, and somebody from the IT team has provided an R&D budget of 50L or 60L, which is absolutely bogus. So the management side of the business people, business orgs should figure out whether or not these type of systems is bloated or not. To do that, management gurus as well as the heads should have also some sort of a domain expertise in AI too. You need to understand a crime when you know what the crime is. Do not fix if it broke. If something is running in an AI pipeline, do not try to fix it. Do not try to tweak it. The more you tweak things, you might break something else which you may not have an inkling of, because AI is somehow like a black box. What happens inside is almost always hidden from us. It's a network of neural weights which is almost hidden from us. So do not try to tweak what already exists and performs well. Hopefully this makes sense for everyone.
Yes, sir.
I'll go into the second part of this. I'll be light on coding today. I'll just show you machine learning. When we talk about AI and stuff, we basically talk about a clever, intelligent algorithm. We have put down a jargon for this: artificial intelligence, deep learning, stuff like that. But the core of it, we can easily say it is just a clever algorithm or statistical system. It starts with this word machine learning. Now we will be studying about uh, machine learning types and where they are used. Since there is a mixed bag of domain expertise here in this participant list, so I'll go with the right hand side first. First thing is the supervised learning, and then there is unsupervised learning. In supervised learning, what we see is there has to be a supervisor. AI will do certain stuff, and there will be a supervisor who will supervise it. That supervisor has to be a human being, may or may not be, but essentially it is supposed uh, to be a human being who will label stuff. Okay, this should have been this. What are you doing? You are not doing right. So make it right. Eventually, the AI system learns from its own mistakes and gradually learns to do it always right. That is supervised system. So in supervised system, what actually needs is two independent things. One is a supervisor, and then number two is data. Umpteen number of data is required to train a particular AI model, so that that particular model learns from its own mistakes by providing its own predictions. Now, I said this word prediction. Now, prediction can be of two types. One is regression, another one is classification. In regression, what we have seen from the last sessions, we started with this called as sales forecasting. We did this. So there is a data set, and we need to figure out what would be the values in the future depending on the historical data. For those type of purposes, we can go with regression. Now, what is classification? In classification, we have a data set. Data set is required in supervised learning, and then there is a teacher which predicts this categories. In which categories do I put this particular set of data into? One of the example is churn prediction. Churn stands for, I mean, I'm not sure about the exact domain expertise. There might be people in this participant list who will be knowing much better than me. Churn is something, say you are a company and your customers are running away from your company. What is the percentage of people or customers who are not taking your product, or who has taken your product earlier, but now they are not taking your product? So that is the churn. Now, in this churn, we can only categorize whether or not this particular product will have a churn or not. Then we can also do something else. We can have business propositions and find out what affected these churns. What was the actual events? What was the actual data that actually caused these churns? So that was about classification. I'll repeat in a nutshell. There is supervised learning, in which we need to have a supervisor as well as labeled data. It is of two types: regression and classification. Regression is a type of machine learning which predicts the future in response to the historical past. Then there is classification, which predicts this particular group of data falls into which category. It might fall into category A or category B or category C, or n number of categories. This was supervised learning. Eventually, we can go here and see we have unsupervised learning. Obviously, in supervised learning, we had a supervisor and data. When we are talking about unsupervised, we are leaving out that supervisor. Supervisor is not required. So without a supervisor, the AI learns from the data in itself. One of the primary objective is clustering. Clustering means we have a set of data and I want to cluster which particular data falls into which particular group. Example is from the, Miss Iyer is from the medical background. Let's say we are talking about radiology. Radiology, we have taken X-rays of the say chest, and if somebody has a pneumonia and somebody has bronchitis or something else, so those are independent classes. And I want to predict those independent classes. I'll straight away go to classification. Reading the radiology X-ray sheets, if we can classify them into independent classes, say pneumonia, bronchitis, etc., then we are doing classification. But if we have many X-ray data plates, I want to put them into clusters, whether or not this is the cluster of, say, a particular city A, that is the cluster of city B, and city B is currently having a pandemic, so we can cluster them into their own symptoms. So that becomes your clustering. One of the useful things in clustering is, again, for the business organizers, is product recommendations. What sort of your clients are buying, what sort of your products. So you can cluster your clients based on their category of products that they buy. Now you can run your customized advertisements. Market basket analysis for mutual funds and all. Customer segmentations. Demography of customers. So these are for your two independent parts. One is supervised learning, another one is unsupervised learning. On the left-hand side, before I go to the left-hand side, am I clear up to now, or have I gone very fast? Just a yes or no will do.
Fine, sir.
Okay.
Fine.
Okay. Thanks. Now, if I move on to the left-hand side, we see we have two more categories: reinforcement learning and generative AI. I will not go into the reinforcement learning. I will say about this, but later on. I belong to this field personally from my academic point of view, but we will start with generative AI. What is generative? The word itself suggests that it generates. In supervised learning, in unsupervised learning, we had one thing in common, which is data. So data was required to learn some pattern. It might be for classification, it might be for clustering, it might be for regression. In generative AI, what it does is it does not require much of the data. Data is only required in the learning phase, but later on it has learned a distribution. Once it has learned the distribution, it can create the same type of data that it has learned in future. Example of users is text generation, which is your chat GPT, image DALI or something else, codes. And basically we are talking about it has learned the data, and now we need not to feed any other data of our own to do a particular job. In short, in very short, this generative AI actually, if I will put it very bluntly, all this supervised learning, unsupervised learning, if I put them and add them up, then we get a generative AI where we have learned from the data. There may or may not be a supervisor, but now in the end of the day, we have a black box. We have a black box which does this. It predicts the next text, it creates images, it writes code. In short, it generates new data from the data it has learned. It is not generally predicting something, it is generating the data from the past experiences. This is a human construct. Human do not learn like this. Human do not mug up the entire world's internet data and spit out words just like ChatGPT. Humans do not function like this. What functions like a human is reinforcement learning. We learn from our mistakes. I'll now go slow. Let's say there's a child and is going to touch a hot kettle. It's filled with boiling water and there is no supervisor. Option number one is he or she will touch it, feel the pain, and if he or that child is dumb, he will not learn. He will touch it again. He will still not learn. He will touch it again. It continues. The cycle continues unless and until the pain resistance increases or that child learns that pain is something which is deteriorating its own health. So it's a self introspection of what my health or what my objective is. If doing an action deteriorates my primary objective, which is in our case survival, then we try to minimize the probability of taking that action in future. I'll repeat, it reduces the probability of taking that action in future depending on how many times I have taken this particular action and what was the result of it. The moment I take an action, there are two consequences. I might get something in a shock or I might get something in reward. Reward and penalty. So based on this reward and penalty situation, we try and make this entire AI to learn from its own mistakes. It does not require much data. It does not require much supervision. It's like a monkey provided with a keyboard and 10,000 years. Eventually, that monkey will write Shakespeare. Othello वो बन जाएगा. So that is how reinforcement learning works in general, and humans work in this particular way. And this is the backbone which is supporting the current generative AI, but nobody talks about this. We are all enthusiastic about generative AI, but the backbone is reinforcement learning. There comes a term called as RLHF. RLHF, which stands for reinforcement learning with human in the loop or human feedback. This H is the person, or this H is the component which makes everything happen, and we completely overlook this. H is human. The moment we put a human in the loop, we said reinforcement learning do not require a supervisor. Now I'm saying introduce a human as a supervisor. That reinforcement learning, that child will learn faster or slower. The child will learn faster. The moment it learns faster from a human experience, the RL system becomes more robust, resilient, and converges first. And if RL works properly, we can create more generative AI systems. Summary: machine learning is a clever statistical algorithms, nothing else. It is the backbone of AI. We have two independent parts on the right hand side, which is supervised learning, and there is unsupervised learning. Supervised learning may have regressions and classifications. Regression is learning from the past historical data and predicting values of the future. Classification is providing or predicting what sort of classes this particular dataset falls into. Then we have unsupervised learning, which is majorly used for clustering a particular set of data into independent groups. On the left hand side, we have generative AI, which generates from learned data of the past. It does not require fresh new data. Reinforcement learning is learning from its own mistakes. This actually is the backbone of generative AI. I'll pause here for 30 seconds and I will wait for any questions. If none, I'll proceed. So there's none. So I'll proceed. Now, today we are going to, last day we were talking about regression. Today we are going to talk about that classification. And we are going to take a business data set only for the churn. We'll go with the simple flow. I'll show you a data set which has all these things. I'll increase the fonts first. As usual, I'm not good with Excels. Is it visible now?
Yes, sir.
Yeah, okay. So I have a data set which has a few columns: customer ID, gender, senior citizen, yes or no, partner, dependence, tenure, and so forth and so on. There are many fields here. We are going to concentrate on the last field, which is the churn. Now, what is churn? Whether or not this particular customer of customer ID, which is this, has left or stopped using your product. I will be very blunt with it. I'm not good with business things. So that is what I understand from churn. So this particular uh, customer has stopped using the product, and that is no. Fine, no, and this is yes, which is it's a loyal customer, and he or she has stayed behind and is still using the product. Now we have n number of rows with all these datas. I'll be very slow and say this. What is my objective? My objective is to figure out if in future I take another row which is unknown and fill up this data of another whatever customer and feed it to my AI system. That AI system should tell me that this particular customer will have a higher prediction or a higher probability of leaving or being loyal to the company. Now, when I have that in mind, that this particular customer has 75% chance of staying in my company or using my product, I will not have much of a problem. If I see that particular client or customer has less probability, I'll look or into the depths of what are the causes or what are the features that is actually resulting in the churn. So in short, I'll try to map this column churn in correlation with all other columns to find a pattern such that in future I can predict whether a particular customer with a new data is going to churn or not. Am I clear with this, or should I explain more? Okay, well enough. So I'll be using this data set now. Before diving into this coding part, again I will be showing a bit of theoretical things. Where is my, excuse me, a moment please. Yeah, I was here. Now from the business background, somebody asked, let's say we are taking this particular use case of finding out the churn or not, and you have this idea. Somebody has this bright idea that I will figure out the pattern from a particular data set of my own company, whether or not that particular company will be churning, or that particular client will be churning or not. Fine. Then that ideation goes into approval. Board will approve it. If it is approved, goes into a blueprint. Then it goes into a R&D prototype. What will these guys do? These guys will be creating that algo. They will be creating that algo for the churn prediction. If it works fine, go with the deployment. If it doesn't work fine, straight to approval of R&D. And if approval is yes, go back to the blueprint and go on. Mr. Murli was asking what should be the time period between V1.1 to V1.2, version 1.1 to version 1.2. If my idea is not approved in the second time, what should be the ideal time period? For a predictive model of such short, a time period should be no more than 2 months. Even 2 months is excessive. Unless and until you are creating a bigger model with an entire zone area of pan India, then the data is huge. Consumption of the AI model will be huge. You are looking around 6 months. That is fine. But if the data is less, you are looking into a zone of, say, Maharashtra or narrowed down to Solapur. The data is small. Your model is well known. Now you just need to fine tune that algorithm. It should not be more than 2 months. That 2 months is also excessive. So first prototype, which is V1.1, 6 months, absolutely fine. When algo is established, V1.1 to V1.2 is simply fine tuning the V1.1 model. Should not take more than 2 months. If somebody is saying that I will be still taking 6 months for it, then this V1.1 was not done properly. V1.1 is the backbone. If that is not done, none of them is going to be done. Am I clear with this for the business people here? Mr. Murli? Okay. Now we are going to go back and dive into this model first, which is our today's session on classification. Say we have a definitive business problem, which is to find out the churn. First thing is define the problem. Next is collect and prepare the data. We already have talked about this, which is EDA, exploratory data analysis, in which we had number one, the data is garbage, and I said garbage in, garbage out. So we need to clean up. The first thing that we need to clean up is find out if there is any missing data. If there is any missing data, either you fill it up or you leave those rows. Then there is, are there any duplicate rows? Remove the duplicate rows. Number three is find out if there are any outliers. If there are any, remove them. Do not try to modify an outlier. An outlier is an outlier, remove it. Missing values can be modified with certain statistical rules like a rolling window, but outliers has to be removed. As simple as that. Next we have, when we have all this, now yes, you can explore the data for your analysis and stuff. Most people from the academic point of view will stop here. They have done the exploration of the data. They have found out their insights, and they will stop further exploring it because they do not want the predictive part. Say, for example, Miss Iyer from medical background might stop here, but from the business background, they might have to do this again, which is feature engineering. Example, let's say we have a senior citizen. Have I identified or specified what defines a senior citizen? We have classified them as, if they are above 60, they are senior citizen. But my company, let's say, sells some telco products, routers, hubs, switches, etc. For me, my senior citizen, this entire parameter doesn't count much or do not provide much any insights into. But if I know what is the exact age of my particular client, then I can figure it out whether or not that client is asking for a discount or a subsidy. If he or she is asking for a subsidy or a discount, whether or not he has ample amount of lifespan left to repay me. So this senior citizen, yes or no, almost all the cases do not make sense. If we had a number of age, that makes sense. So feature engineering is more important. Here, a number would have been much more important. I'm just asking from the business people here, is my proposition of saying that senior citizen should be a number for a telco selling your routers, hubs and all, or a service, is right or wrong? Okay, no answers. Then I will be going forward with this. Now we have this data set and we are going to provide a particular feature engineering. So we have said that senior citizen can be put into a numbers. For example, for me, it should be 56 for my company. For some other companies, it might be 70 and all. Once we have done the feature engineering, this is something new, which is split the data. Splitting the data is, I'll go with the concept first. Let's say I have a big bunch of data, a class full of students, and I want to predict whether or not this particular student will flunk in a particular course or not, based on that particular your past results. If I take for the training part, if I am the faculty, if I am the teacher, and I take all the files of my students with all the results and start creating a statistical model to predict all this, whether or not that student will be flunking in a class or not, what will happen in the end? My training was on all the data. There is no such data left on which I can test. So if I have to test, I'll have to have a fresh student data. If I have a fresh student data and I test my model, my algorithm on this, how would I know whether or not my algorithm was correct or wrong? Because I have taken all the data of my students, I have created a model, and I believe there's a belief system that my model is right, my statistical model is right. I have no other way of proving whether or not my model is right or wrong. So instead of that, what we can do is the entire data set can be split into two parts. One is train, on which we will be training. Another one is test, on which we will be testing. This test part, this also is also a part of the data which we have. In business propositions, we call this back testing. If we have some sort of a data left, which we know what are the predictions are, then we can also predict whether or not our algorithm is right or wrong. In essence, we keep approximately 80% of the data for the train and 20% of the data for the test. So in this particular data set, how many rows are there? We have, how many rows are there? 7043. For this 7043 rows, what I will be doing is I'll take 80% of the data for test and the rest for the train. I mean, 80% is for the train and 20% is for the test. Now 0.8 into 7043, which approximately amounts to, so I'll be taking 5634 amount of rows for training my own algorithm, and I'll be taking 0.2 into 7043, which is 1408 number of rows for my testing. Is this clear? Okay.
Yes. Yes, sir.
Okay. Now the major part, another part remains, which is I have taken 80% is for train, I have taken 20% is for test. But if you look into the data set, we are actually trying to predict this last column, which is my churn. And it has two categories, no and yes. If the first 5600 rows which I'm taking for the train has this sort of a data set distribution, say I have taken 5600 rows for train, in which I have 5000 data rows which has yes for churn and only 600 for no. Do I have a balanced data? Balanced, the word is balanced. If
No.
the data itself is not balanced, what am I learning is my learning is too much biased on, why is this so big? My data is so biased on this, the class which is heavy, which is yes. I'll be learning more of the yes part rather than the no part. So I have one more step to do, which is I should have a completely balanced data. Now, to make our data balanced, what we need to do is I need to, again, let's say we have 5000 for yes and 600 for no. I can do one particular thing called as an interpolation. Interpolation is putting values in between two independent values based on their average. So I can interpolate this data such that I can have some sort of a balance, like 5000 for yes and again 5000 for no. In this 5000 we had 600 original and the rest 4400 are synthetic or created data. This goes absolutely fine with business platforms, but people who are from the medical academics and all, be very careful while you are creating your synthetic data. This will create a lot of discrepancies in your projections of your empirical data set, and hence your empirical results will not match the real world. The marginal of that not matching is around 2 to 4% in general. For business applications, 2 to 4% of not matching the projected one is quite fine for a longer period of time. But for medicals, for academics, 2 to 4% of mismatch is ruining your empirical results. So be very careful while doing this data balancing. Am I clear with this, Miss Aya?
Yes, sir. Yes, sir. We do this type of analysis, sir.
Anji? Yeah?
And yes, sir. We are familiar with this type of analysis. We do training and testing. Huh. Yes, sir.
This has to be done, and the data has to be balanced, but be very careful with the synthetic part. Business people
Yes.
have got no problem. We do have a big problem.
Yes,
Then
sir.
we do something called as a random forest. This is just one of the classification models. I'm just talking about just one classification models. There are n number of classifiers. For example, XGBoost. Then we have say decision tree. Random forest is a part of your decision tree and
Yes,
all.
sir. Yes.
It's fine. So there are n number of things. We have to create a particular classifier and use this. Most importantly, in modern days, we have the most important black box, which we do not understand well, which is ANN, which stands for Artificial Neural Network. These we do understand. XGBoost, yes, we know. Algorithm, we know. Decision tree, we know the algorithm. Artificial neural network, yes, we do know partially the algorithm. Do I or can I interpret or what's going inside? Not really. AI is completely blind when we use this. I mean, not AI, but humans are completely blind as to what actually is happening inside when we use ANNs. But when we use statistical models like XGBoost, decision tree, and random forest, it is absolutely under our control. Once we use this model, we can evaluate the model. Evaluate the model on what? We train this model on the train data set. We evaluate the model on the test data set. Unless and until we have a fair amount of percentage of accuracy on this evaluation of the test data set, we go on training this. Unless until we have that particular required accuracy. Once we have that, when the performance is acceptable, then we analyze feature importance. What is feature importance? What are the parameters? For example, over here, what are these parameters? Streaming TV, streaming movies, contract, paperless billing. What are the parameters that actually contributed to the end goal? For our case, in this particular case, we have churn. So we need to figure it out. This is the most important part for business people. We have done a lot of training. We have created a model, but at the end of the day, I'm not getting my business insights. If I'm not getting my business insights, what is the use of using a AI, ML, and stuff like that? End of the day, I need to make money. For academics, end of the day, I need to make my decisions on which I will be carrying forward my empirical results. Then, when we have all this settled down, we can generate our predictions on new data. This is only for the business models, business applications. What are the parameters which are at risk, or some other insights? I'll not go into the depth of it. Design interventions is part of both academics as well as business. Do we need to change the model? Yes or no? Here lies that version 1.1 to version 1.2. Do I need to do this, which is fine tune the model? If I am not satisfied with the model, obviously I need to fine tune. My versioning then changes. This fine tuning requirement is almost always required in a business model, and the time required, lead time of the R&D team actually decreases. V1.1 highest and goes exponentially down along with the prototypes. Once you are ready for deployment, yeah, do it, deploy and monitor. That's the entire life cycle of how a classifier modeling is done from end to end, the turnkey way. Hopefully that makes sense.
Yes, sir.
Okay. Now that we know what is to be done exactly, we skipped a part called as a random forest. What does random forest do? I'll not go into the depth of it. I'll just provide a brief, very brief overview of it. let's say we have a customer data and I need to have some sort of a predictive model or classifier model. What it does is, the name itself suggests it has got trees and it is random. So let's say I'm God and I'm playing the game called creation. I have a huge number of trees and I have a lot of barren land. And I'm trying to figure out which part of the land will be a desert and which part of the land will be a fertile land. And I have a bunch of trees in my hand. I'll go on planting them one by one, experimenting whether or not that land is, that soil is all right or not. I'm God, I should know. Let's say I do not know. I have planted a few. I have got a result that that particular soil is not right. What I will be doing is I will go into the next one. So I'm going on planting trees, finding out the right ground where I have a good decision to put all my trees. So that is what we are doing. We have a customer data. We are going to take decisions and we are going to plant trees along the way. All my trees are actually decision boundaries. These are decision boundaries. The name itself says we need to take a decision and we should have a boundary for that. Boundary means a threshold. So first we took a decision. Tree 1, it says, is that tenure less than 6 months? Okay, yes, then it's high risk. If no, low risk. Tree 2, it's another decision. What is the boundary here? We say support tickets is greater than 3. What is my boundary? 3. What is my tree? Support tickets. Support tickets is my tree. My decision boundary is 3. If yes, goes here. High risk, low risk, high risk, low risk. Every single one is classifying this into a high risk and low risk. Tree 3 is usage is declining. And this is, we have shown only 3 trees. Based on your use case, there will be thousands of trees, thousands of questions that has to be answered with a particular number in mind, whether or not this is greater than this or not. Out of all this, now we have the decision of all this trees. These are my decisions. Now what do? I have a lot of MLAs, MPs in my country, and I have to take a vote. Which MLA is right and which MLA is wrong? End of the day, none of them is right, but let's say some of them are right. So we have to take a majority vote of which particular decision is right. And after taking that vote, we say, okay, this one was, this particular customer will be a churn. So my model says customer 1 is going to churn, which is true. But my actual ground truth says, let's say I say this is my prediction. This is my prediction P, and this is my ground truth GT. My prediction says it is going to churn, but my ground truth, which is from the example itself, it says no, that guy will not churn. So my ground truth is F, false. So my model is not right. What it will do is, it will not actually provide a true, it will not actually provide a false, it will provide a percentage. Now what I say is ground truth minus my prediction. Ground truth is false, my prediction is true. Ground truth was 0, my prediction was 1. 0 minus 1 is minus 1, but that doesn't make any sense because that is a negative number. Let's square it. What we have in our hand is a loss. Just a simple loss. Now, if I take a prediction for all of them, let us put a prediction column here. And let us say that in this prediction column, we have said yes. Here we have said yes, and goes on. then we will be having something, a loss for all these columns. I can compute the loss for each column, that is my loss. And also we can do one thing, which is I can put a summation of I to n. N is a number of rows. I'll write it clearly. Summation of I to n. N is the number of rows, and here is GT minus, that is my ground truth, minus predicted square. What are the terms used here? We have done a square, we have done a summation. What if I want to have a single value? I can do this by n. So eventually what we have is, we have taken a summation of the losses divided by n. Don't we have something called as a average of all the losses? If I have the average, we can call it as a mean. The word is mean, and we have done a square. So we can call this least, or let's say for the time being, least mean square. Mean square loss. Now tell me, just in a yes or no, this least mean square loss should be going down when we have started the training. My objective is to keep this loss down or keep this loss
Dr.
up.
Banerjee,
Yes.
Dr. Banerjee, just I would like to ask the audience your opinion, because already we are 20 minutes late. So if they have no objection, we can continue. Otherwise, we have to pause, because it was scheduled up to 5:30. So if the participants have no problem to stay with us, then we have no issue. So just participants, whether we should continue or stop for today. I am ready.
Continue, sir.
Okay, so thank you. Thank you. So please
Okay, I'll be brief then. I have taken out a lot of time, so I'll be very brief with this. Are we clear with this? Do I have to increase this loss, or do I have to decrease this loss over time in training? While we are training, while we are learning, do I have to reduce this loss or increase this loss? A single word will do. Participants, do I have to reduce this loss or increase this loss? And I can wait for an hour for an answer. I've been a teacher for a long time.
Reduce.
Reduce. Remain to
Yeah.
reduce.
Yeah. So ultimately, we have to reduce this particular loss. We call this least mean square. Sounds heavy. Let's call this simply a loss function. Now we are going to implement this in a simple code, not much, simple code with this particular data set only. Now we'll dive straight in the code. And as Dr. Thakur has been aptly said, that we need to use collab. Not my favorite, but all right. Let's say we have customer churn. I'll just show this and stop, because let's start with this. And I'll be sharing this notebooks with the participants. And data set is something, this code itself will download the data set. You need not to worry about it. So first we'll go with all these things are the libraries that we need to import. Path library, path, warnings, matplotlib, and NumPy. NumPy and Pandas are the two libraries used for data processing. Seaborn and matplotlib are used for the plotting. So these few lines are something, not these two, but these few lines are something. If you are writing your own code in Python for data processing and ML jobs are almost always mandatory. This is a boilerplate. We'll have to write this. This is something new, which is sklearn. Sklearn stands for scikit-learn. It's a library specifically designed for machine learning, or that random forest, decision trees, all those decision boundaries. Do I have to code that? No. It is already coded into a particular library and we are just going to use it. That library name is called as a sklearn or a scikit-learn. We simply call random forest. We simply call. Last class, in the last session, we were talking about regression or a linear regression or a logistic regression. We can simply call that. So one line of code can call an entire library which can be used for your logistic regressions, for your random forest, for classifications, for regressions and all. This is very important. Column transformers. Why? Because as I said, garbage in, garbage out. We need to clean our data. This is machine learning. Machine do not talk in words. It talks in numbers. So we need to put every single data points into numbers. Do I have them? For example, contract. Is it a number? No. Paperless billing. Is it a number? No. Payment method? No. What we can do is we know that contracts are of certain types and that certain thing is finite. It's not infinite. So we know specific number of contract types. We know paperless billing will be either yes or no. We know payment method will be of finite types. So what we can do is we can put a number. Month to month will be 1 year. Sorry, 1 year will be 2, and so forth and so on. Do I have to do it manually in the data set itself? No. There is a thing called as a column transformer which will be doing it for us. So column transformer is mostly used to transform your linguistic columns into numeric columns. So all columns which are basically linguistic in nature or categorical in nature will be transferred into numericals. Another is this we have already said. Now comes what are the metrics that we are trying to figure out on running these two models. Let's say I'm going to run random forest. What are the metrics that I'm trying to figure out? How do I know whether or not my model is performing well or not? We already said we have a least mean square error or a loss function. That loss function is a number. Very good. How do I calculate that? We can calculate that using accuracy score. That is one of the metrics. Then we can have a classification report. We can have a F1 score, precision score, recall score. All this will be done in future. But these are the metrics that the model is actually looking for, or as a human, I am looking for in the model. Unless and until my F1 score is fairly high, reaching 1 in a scale of 0 to 1, I'm not going to stop. Unless and until my accuracy score, which is another value between 0 and 1, is not reaching near 0.99 or 0.98, which is 98%, I'm not going to stop. I need to specify where is my stoppage. That stopping has to be specified by me as a human being. I can stop at 70 also. Now, after all this, we already said we need to split my data into two independent parts, train and test. Who will be doing it? Not me. There is a slave called as scikit-learn. He will do it. And we have this train test split. It will be doing this stuff. Next, we have a pipeline. Dr. Thakur had been saying this word pipeline umpteen number of times. All this block that I have been showing, where was it? Does this not look like a pipeline? Define business problem, collect, prepare data, explore. This looks like a pipeline, and somebody has to put this pipeline into practice. Am I going to do it? No. I'm the designer who will be designing the pipeline, and somebody has to execute that pipeline, and that execution part is done by this scikit-learn. So I'm first defining my pipeline. I have said that my pipeline will have that particular thing called as a random forest, and I also said that I also have linguistic parameters. I need to transform them into numeric values. To do that, I'm going to use one more thing: one hot encoder and a standard scaler. In our previous sessions, we said if all values are not in the same scale, my prediction will be almost always wrong. So I need to scale everything up. Example, my price of a house is in crores, in CRs, whereas number of bathrooms in the house, number of living room in the house is in 2 or 3 digits. If I use these two columns in a house price prediction model, my model will be more biased on the house price itself rather than the number of living rooms and stuff. So I need to put everything into a scaling proportion. One of the easiest way of doing that is normalization. That will put everything into a value or scale of 0 and 1. To do that, we have a standard scaler. Next, these are for just the printing part. I'll leave this the thing. This is important. Load telco data. Telco is for the non IT and business people, is telecom companies like Reliance, Jio, and stuff. So we are going to load a telco data, and it's an actual data of a NAS server procurement. For that, we are actually downloading this from internet itself. So when I will be providing you this data set, I mean this code, the code itself will be downloading it from the internet. You did not to worry about that. This is the URL from where it will be downloading it, which is exactly this one, this telco. Now, once we have loaded this data set into a particular where I need to load this into some bucket from where I can do this analysis. That bucket is handled by this particular pandas. This is for the data handling, as well as NumPy, which does the actual compute. Pandas is the one which handles the data. In organization, there is a group of people who handles the logistics, the files, and drawers of files and stuff like that. That is pandas. And there are people who work on the accountancy, actuarians and all. That is NumPy. And then there will be managers who are going to do a presentation on the board. They will be doing it with this. That is matplotlib. So these are the presenters. These are the accountants. These are the data custodians. Now we have this data. We have loaded this data into a particular thing called as a DF. DF stands for data frame. Data has a frame, so data frame. Now the first part is this. This is your data frame. You will still notice we have linguistic columns, female, male, then partner, yes or no. We need to transfer them. Next thing is data preparation. First thing is we are cleaning the feature preparation. First, total charges. If it is numeric data, do I have any sort of missing values? Then I will be doing what? I can either impute or create my own data, or I can remove these rows. Notice here we have something called as a DF, which is the data frame where my data is. I'm saying that guy who is handling my data to drop NA. NA stands for null. So if there is any column where there is NA not available, then please drop those columns. So missing data is handled here. Then we have this churn flag. My last one, churn, was yes or no. but I cannot handle yes or no. It is linguistic. So what I will be doing is I'll be transferring that into as type as integer, which is between 0 and 1. It will be either 0 or 1. So I transfer that into a type integer. Next, when we have all this, we see that how many rows have removed invalid total charges, which is they were missing values. We removed them. 11 of them are gone. Final modeling rows are this. Overall churn rate is this. Exploratory business data analysis. First, we did a plot of contracts. What are my churns and stuff like that. This is also an important part in business. You need to do some EDA if you have to show to your boss and all. What we did is churn rate by contract type, and then there's a churn rate. And where is this saved as? Saved as 0 to customer churn EDA. We'll go over there. Oh, I haven't. One moment. I haven't run this. At least run this once. So for data preparation, let me run this. We will have a plot of EDA, which will be in the file as 0 to customer churn EDA. We have got this plot. Let me how do I show it? Okay. Open a new tab. This is the data that we have got from the churn. You see month to month, 1 year, 2 year, no and yes for churn monthly. We see that churn rate increases more when electronic check is done. When the electronic checking is done, when electronic checking is the primary mode of the parameter in which we see a lot of churns. This is one of the exploratory data analysis that is done here. Is this all? No. We can have a number of other data sets also. Once this data set is done, exploratory data analysis is done, you can do a lot of them. I've just done only one. The most important part is test, train, split. I said 80-20 split is the industry standard. What if we do not do that? That is what we have suggested here. Let's do a 75% train and 25% test. Had we done an 80% train and 20% test, I would have got more data to train on. Absolutely fine. But will the model be more generalized? No. The less amount of data I provide the model and ask it to work harder to become more efficient, it will be a generalized model. So I've reduced it to 75% for train and 25% for test. Next, we are going to do a model training. This is important. What I was saying is target column is churn flag, but you notice the target column was simply churn. Then where is my churn flag column? Have we made that earlier? Yes, we have done that earlier here in step 2. Where? In this particular line, we have created a new column churn flag based on churn as an integer, which is 0 and 1. I've been talking for long. Is this understandable? Okay.
Yes, sir.
Any doubt, please clarify. Talk to me, I will clarify. Okay. Now that we have all these columns set, we do not need unwanted columns. These are the columns which do not make any sense in prediction. What will my customer ID have any sort of relevance to this classification problem? It will have no relevance, so customer ID is dropped. We have already created a churn flag. Do I need the old churn column? No. So I'm dropping that. Why am I dropping this churn flag now? Because in test data set, in testing data set, I have to make it completely blind. In short, my train data set will have this churn, eventually the churn flag. In test data set, this will be completely blind. If this column is not blind, then the model will not understand. I mean, I will not understand whether or not this model has learned or not. If the model is all omnipotent and seeing through my test cases, then I'm not actually testing it. So I need to have this column while testing, I mean training, and this column removed while testing. Now back to this X and Y. In the first session, we have already said AI is all about mapping Y to X and X to Y, and to find out the function in between. Y is equal to f of X. We need to find the function. So here we are defining the X. What are my X? All the feature columns. What are my feature columns? After removing all these three, whatever is left are my feature columns. So X is my feature columns and Y is my target column. Target is churn flag. So I'm trying to figure out the relationship between my target churn flag and my feature columns, which is the rest of the columns after removing these three. Now comes all the columns which have the linguistic values has to be transferred into numbers. So I'm saying all the categorical columns, find all the categorical columns, I mean the ones which are linguistic and the other ones which are the numeric columns. Once that is found, we have to do a simple pre-processor. Two things is done here. One of them is we are scaling it. Whatever is my numeric columns, I need not to do any sort of linguistic to numeric transfer. They're already in numerics. Let them be, but I will have to do a scaling on them. Whatever is my categorical columns, I'll have to transfer them into numbers. To do that, we have one hot encoder. We are encoding categories into numbers. Once that is done, we are defining the two independent models. One is logistic regression, another one is random forest. Logistic regression can also do classification, so we are going to use that as a comparative analysis. And the next thing is what we will be doing is simply run them up. How do I run them up? I first say these are the metrics that I am looking for. You need to provide all these metrics with all these names, and I need the accuracy, precision, recall, F1, ROC curves, and then you simply call them. I mean, you simply call the model itself. How do you call the model? You define this pipeline and run them up over here. So let us run this model. You will see there is a class balance. Churn 1 is simply 26.58%. I said balanced. If a balanced data set has to be there, the percentage should be 50-50. 50% of such a class, 50% of that class. If there are more classes, then equally distributed. But we see a balance of only 26.58, which eventually says that this data set is imbalanced. Still, we have from logistic regression, we have accuracy of 73%, and from random forest, we have a accuracy of 76%. From my last few words, what should have been done to increase this accuracy to almost 90 to 92%? What have we missed? There are a few things, 2 or 3 things that we missed. but we talked about. I'll give you a hint. One of them is we did not remove the outliers. Outliers make a lot of difference. We did not do that. Number two is duplicates. We did not remove them. Number three, right now I said based on this number, 26.8% is what should have been done to make sure, to at least make sure that these predictions would have been above 90%. I'm just asking. Data should be balanced or imbalanced?
Balanced.
Balanced. So is this fine or not fine?
It's
No,
not.
so
It's
no,
not
sir.
fine. It
Yes.
should reach, this balance should reach 50%.
50%.
Yes.
One of, equal proportion of each class. But we do not have equal proportion of each class. One of the class is heavy. So it's a heavy tailed distribution, and hence my prediction will be biased towards that particular class. Do I see that? We see precision of 49, 0.49, here 0.54. Recall is very high. F1 is less than 0.9. We do see a problem with this model. So we need to have a balanced data set. I said we need to have a balanced data set. Now we know by empirical results as to why, because the numbers do not lie. Numbers are saying we need to have it. Now we go for an evaluation of this model. All this accuracy, F1 and all, I'll just simply plot them up, and results are at confusion metrics and all. So we have customer churn, EDA, customer churn, confusion metrics. Now what the hell is this confusion metrics? I need not to explain to anybody what is this confusion matrix is, because a closer look will eventually say what it is. On the left hand side, we have a true label. That is what we were talking about, the ground truth. Here on the bottom, we have predicted level, which is what the model has predicted. So retained, that is no churn, was actually predicted by the model as 95, but they actually have churned. The ground truth says that 95 people have churned, but the model has predicted 95 people as not churned. Same way, the model has said that 917 people have been retained. Ground truth also says so. So this is a good number. But by logic, what should have been a better confusion matrix? A better confusion matrix should be more number here, exactly diagonally, more number here. These two should have been almost zero. Why? Churned and retained. Prediction is churned but retained. So this is a false prediction. This should be zero. Retained and churned is a false prediction. Should have been zero. This two should have been extremely high. This should have been much higher, 1,000, 2,000, based on the number of rows. This should have been also higher. So your confusion matrix for a good model should look like deep blue here, deep blue here, absolutely white here, absolutely white here. Am I clear with this?
Yes, sir.
Now going back here, churn model evaluation. What has been the evolution of this model? Now we have used two independent models: logistic regression and random forest. Accuracy wise, precision wise, recall. Recall is important. Recall, most of us we try to forget, but recall is important. Recall is something that you in a layman's term is something like you threw a stone in a pond, and your objective was to make the stone skip on the pond surface, but it did not do that. It drowned. Had it been a proper skipping stone, it had gone forward. Forward means higher number. Recall should have been much, much less. I would have recall is something that like what is my expectation and what have I achieved. So my expectations and achieve, the difference between that is recall. The difference should be less, but I see a lot of recalls here. So this should have been higher. Now, some other things for the business perspective. These graphs or plots is quite good for somebody who is doing a modeling part or doing some exploratory data analysis. Fine. If you have to run to your boss to create a presentation, do this make any sense? No. For a business meeting, what makes sense is insights. So what are the parameters which eventually resulted in the churn? To understand that is more important for the business perspective rather than this. So we are basically talking about this. Now, where was it? Analyze feature importance. Which features were important and which features were not. This is also important for academics. Also, we need to understand what parameters eventually resulted in the particular set of results and why the other parameters did not. So parameter sensitivity. What I mean by parameters are the columns, names. So we will do a key feature importance. How you are doing this feature importance? Do I have to do some sort of a magic or some sort of a statistics behind it? No, we need not to do anything. Why? Because that particular thing called scikit-learn does that for us. So we have simple raw importance equals to model objective dot feature importance, and that's it. It will calculate the feature importance based on a model called as an isolation feature mapping. So it will do that and it will be providing you. Let's do that. Once we have this, we see that tenure is more important. The importance of tenure is the highest in determining whether or not a particular client will be churning or not, and followed by the rest, contract 2 years, so and so. All these are of from the highest to the lowest importance. And at the beginning of my session, I was talking about tenure in itself. What and how? I said senior citizens. Should they be considered as a simple binary? Yes or no? Or should I be talking about their actual ages and the discounts or the loans they're asking for, or how many days they are going to take my products and all? So that age is important. That tenure is more important. From a telco perspective, for as Mr. Murli is in, if you are providing a service to a company for a particular network services, then the lead time is also important, and the exit period that the client approves. Say after a disapproval of or discontinuation of the particular service in a particular institute, how many days are left? Is it 15 days, 30 days of exit time? That is important. If a client is asking for a 15 days exit, then that client has an intention of churning out from your service. So this sort of an ideology or this sort of an insight is more important. Now, risk scoring, how much low, high, mid, and critical. That is also a part of business analysis. Now we have these parameters, which eventually says from the top to bottom, which are the parameters trying to put up, relevance to my churn predictability. But then there is a how much. If I have a new client, then I need to say to my boss, this particular client has so and so much of risk in terms of either a predictable, probability, 27% is 75%, or I can divide that into single bands of high risk, low risk, medium risk. Mostly these are the bands. So if I divide this, you will see I have a bin here. Bin stands for how much the scaling is. 0 to 25 percentage, 25 percentage to 50, 50 to 75, then to 100. But at the end of the day, this classification model will provide you that probability. What you are doing now is something extra. You are providing a bin for that, and you are classifying them into independent bins. In academics also, we need to sometimes put things into bins. For example, in medical, a simple probability of acquiring a thoracic bronchitis from a X-ray is not sufficient. We have to put them in a high risk patient, low risk. So this particular binning is almost always required. Now, if I do this binning, we can have which particular customers have, or what cluster of customers have the highest percentage of churn probability. So average churn probability we see critical is, oh, it's almost 83%. Is, 1460 customers have 83 percentage probability of churning, which is quite a high risk situation right now. It's a very critical situation. Had I seen this as high and all are low, I would have gone back and studied this. I would have taken the first tenure and taken my business policy out of it. But when I see all of them are almost of the same side, 1460, 1451, then I have to take the median, or at least 10 or 5 of this. In short, if this was the highest and all were very far off, I would have taken only one, which is the highest. Had this been mostly balanced values, so there is a balance of critical, mid risk and all, I would have to then take hold of all or some of the top ranking features and take my business policy out of it. What are my business recommendation? I'm leaving it up to you. And right now I'm quite tired. Is this session okay? Was this session okay? Did you understood at least something?
The
Okay.
last part was a little fast, sir, but otherwise, mostly, yes, sir, we understood. We have to use Google Colab for this.
You can use anything for this. I was asked to use a Google Colab because it is easier for you to start with. You can use
Okay,
VS Code IDE. You can use a normal Python also.
okay, sir.
Understand the programming logic rather than
Yes,
the
sir.
programming,
Yes, yes,
paradigm, Python
yes,
or C++.
yes, sir.
That is the flow. You can have n number of syntaxes for any other programming languages and use them in your language. You can use R. You can use Python, C, C++. It is all up to you. But the logic is where the human resides, and human is the driving backbone of all businesses. At the end of the day, for academics, we need to have good results to be published for the betterment of mankind. At the end of the day, we need to have a better models, predictive models for good money. So objective is set by humans, models are created by humans, AI is doing our mundane jobs. Keep it that way only. Do not
Yes.
ask AI to do this and go home and sleep.
Yes.
Any questions? I'm here for another 4 to 5 minutes. If you have any questions, please do ask. None. So I leave it to it, that only. Should I close the session now?
Abhijit sir, I just wanted to know while writing this code in the starting, what you wrote that we have to write in each coding thing to create something, all that things that
Yeah,
cycle and panda
you
and
have to
everything.
import the models. Uh, See, you want to do something regarding data, and you are not going to do it by yourself. You will be using the slaves. The slaves are these libraries. Then you need to summon them every
So
single
should
time.
I should keep a note of all these things what you have taken up, and if I suppose if I am doing it on my own, I have to put all these things and then create a language of
Yep,
like this and go ahead.
yep. This particular cell, this
Okay,
particular line of code has to be there in every single one of your next codes. It should start with this. Absolutely.
okay. Okay. Also, I would like to know one thing. I am from a engineering background. I am a chemical engineer and
Hmm.
I'm working as a design consultancy firm.
Hmm.
So I am very much new. I means you can tell that as a fresher, I am seeing all these things. So if I have to do something regarding in engineering and everything,
What
what
specifically do you do?
I am into designing of chemical refineries, fertilizers plant, pharmaceutical plants.
Does it have to do anything with bonding, polymer bondings and all structural?
Uh,
I mean, do you do R&D?
No, we are not into R&D, but we are into designing. I am a piping engineer, so we are into
Then you need
pipeline.
not to go for coding. My advice is your primary lookout would be for a no code platform. For
Okay, so
example, Dr. Thakur had been showing something called as a rapid miner, Altair.
okay,
Go for a no code solution. I have already said, do not reinvent the wheel. This will be too much for you, this
yes,
code and
yes,
all.
that's what I'm trying to understand it.
Go for a no code platform, feed your data, get things done. But at the end of the day, you need to identify, do you want your objective to be a regression one, or a classification one, or a clustering one? So based
Okay,
on that, you need to choose your uh, models. And most no-code platforms have a simple black box system like regression, classification, and others. You need not to do anything about it. In the next session, which will be tomorrow, I'll be going all about no-code.
okay, sir. Thank you so much for this.
So one question, sir. So
Yeah.
for medical data, like I have population data and I have cancer registry, this prevalence of cancer, and I want to do a prediction model. Uh, uh, is there some kind of resource material or examples or some like in GitHub itself where I can get some sort of help as to how to go about the model?
What specific type of data are you looking for? Cancer data, maybe many number
From
of things. I mean, is it a
cancer
biopsy data?
Sir, cancer registry prevalence, sir, in
Cancer
epidemiology.
registry prevalence.
Huh.
Okay.
Yes. So we are seeing number of cases they give per lakh of population, and we're seeing like I know the growth of population. I know the rate. Can I do? First, I'm asking if I can apply prediction modeling in for to look at number of cases of cancer that.
See, your prediction has to be first idealized into in one of these things.
Yes,
Since
sir.
you have a prevalence data, which
Yes.
is not talking about regression, you're not
Yes.
talking about predicting what will happen in 2027. Your data is mostly about clustering as well as classification. You need to classify which
Okay.
particular patient will have a probability of
Probability.
cancer or
Yes.
not. That is
Okay.
one of them.
Huh.
Another is you have a cancer prevalence data, which is a demographic data. For
Yes.
example, in Solapur or Nagpur, you have so many people have so many symptoms, and they are classified as already classified as having this particular type of cancer. Now you want to cluster them. That can be done. So you are looking into classification or clustering. When you are
Cluster.
looking into classification and clustering, then you need to have an immense amount of data, demographic one,
Huh.
from the site itself.
Yes,
One,
from
one of the
data.
best site is gov.in. Government provides beautiful data.
Yes, sir.
Almost 99% is hidden in junk. You'll have to go and hunt in their site to get that data. You need demographic, tensor, privilege data. CIDC and CDC both provide their own data on registration.
Family health and welfare, we have
Yes,
also.
they also provide you data, but you are eventually looking towards classification and
Clustering.
clustering. Your
Okay.
job is not for regression analysis.
Okay, sir. Okay, sir. Thank you, sir. Thank you.
Any other? Okay, Nandan.
Abhijit sir, could you please provide this program file along with the data set?
Hanji, I'll be doing that. Did you get the last one?
Yes, last one I have.
Then I will be providing you this also.
Thank you, sir.
If all done, may I leave?
Thank you, sir.
Yes, sir. Thank you.
Yeah,
Thank you.
then Mr. Datta is there. Please conclude the session. Mr. President.
Thank you, sir.
Okay, thank you, participants. I believe the organizers.
So no one from the organizers? Okay,
I think
thank
they
you.
are. Yes, thank you so much.
So thank you for remaining
you.
with us. Okay, thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Tomorrow
Thank
3 p.m. again, no?
Same time, right?
Yes,
Yeah,
sir.
tomorrow same time.
Okay,
So
thank you
we'll
so much.
session recordings if you'll get, sir.
See,
Maybe
we
we'll
are
get-
the ones who are going to. We are the educators. We are not part of the organization. They might have an answer for it.
Thank you, sir. Thank you.
Okay.